You are listening to a piece of the Salasin.10 podcasterium. You are listening to a piece of the Salasin.10 podcasterium.
Platform next extended for Kuala Lumpur State. My name is JT. I'm the one who will email you all for all the things. Thank you for coming. And all right, let me introduce what is Google Developer Group Kuala Lumpur. Okay, Google Developer Group Kuala Lumpur is a community of developers who have the passion to share and to learn from each other as well in regards to Google technology. So we are supported by Google, but we are not working for that. They support us in terms of materials, collabs, and speakers. So you're very welcome to join us here. Okay, so Google Cloud Platform. Nowadays, with the rising of internet, as internet speed going faster and better than ever, most of our applications now are moving from traditional offline-based application towards cloud. So previously, when you do, like let's say word processing, previously you do in offline applications like Microsoft Word. Now you do it online. Previously, if you need to do some image processing, some photo editing, you do it via Photoshop offline. Now you are able to do online. For example, Excel. And more business moving from offline to online. So in order for us to do that, so we can use it in a cloud environment. Right now we do not need to do something like set up our own server. Nowadays we do it on the cloud. For example, in my company, from where I work, my company has only 2 developers. But I'm working for a company named Table App. It's one of the largest restaurant reservation system in Malaysia. Yet we operate from 2 developers. So how can we do that possibly? Is because we move most of our infrastructure to the cloud. So we can focus on the code instead. So right now, this Google Cloud Platform Next Extended is for us to inform you guys about what's the next and greatest about the cloud technology. So without much further ado, let me introduce our first speaker, Mr. Moritan.
Good morning.
Morning.
Okay, thank you very much for having me. Let me start with a video.
Cloud's fascinating because really what it's done is it's completely changed the speed of innovation. From hosting websites, compute engines, to data prediction, it offers the flexibility that companies need now. It's what makes cloud and Google Cloud Platform very, very important to our businesses.
I grew up just absolutely loving visual effects. When we started comic fiction, one of the most challenging parts of doing visual effects is rendering. It takes an immense amount of computing horsepower. Using Google Cloud Platform, we have massive infrastructure off-site when we need it, and then nothing when we don't. It helped us put the resources on the artists and making sure that every penny that our clients spent made it up on the movie screen.
Khan Academy's mission is a free world-class education for anyone, anywhere. Google Cloud Platform allows us to stay focused on learner outcomes because our infrastructure has become this invisible layer that we don't have to worry about anymore. Keeping track of that much data for millions of students every day is a challenging problem, and storing all that data and being able to quickly act on it and look at it is really core to our mission.
The name Pocket Gems really speaks to what we do, which is make beautiful things for your mobile device.
For War Dragons, in minutes or hours, you might have hundreds of thousands of players playing your game. If you don't have the server infrastructure, your server is just going to explode. Google Cloud Platform allows us to be able to scale automatically. We don't even have to think about that. Your backend just works. It's almost magical.
Payments are the connective tissue of economies, and that really resonates with Know It Anywhere. We are providing payments in the massive underserved markets.
Hosting our application on Google Cloud Platform gives us a much higher reliability than we could have got hosting it ourselves.
We're really able to move the needle and make those payments available and affordable everywhere.
The mission of Spotify is really about being a great musical companion and making it more personal.
Moving to Google's Cloud Platform enabled us to take use of the scale that Google can provide.
The reality is it's quite hard to build great data centers, and that was really the driver into Google's Cloud Platform. The less time that we can spend solving problems that are already solved, the more time and energy we can spend on turning our data into value.
We wanted to make this marketing campaign for Coca-Cola something that every single person could participate. Submit your photo, you can be on the flag in the opening of the World Cup.
It was a gigantic scale. We did not have time to set up an infrastructure and set up the servers. By using Google Cloud Platform, we went straight into building on top of it.
Fundamentally, it gets down to one word, it's trust. The same infrastructure that powers the Google search engines is what's powering the cloud that Coca-Cola is running on.
How's that? So, let me introduce myself. Can you all hear me? Yes. Okay. So, my name is Naoya Moritani. I'm a sales engineer from the Google Cloud Platform team for Asia. I'm based in Singapore. Before I get to do a little more introduction of myself, it would be great if I could know about you a little bit more. So, I know there has been some surveys that went around before this event registration, but if you have your phone, if you could just scan this QR code or just access this URL and submit the form, it would be really helpful so that I can know what you're interested in, what your background might be, how much you've been experienced Google Cloud. And I've also added a field for that last minute request for the content for today. So I'll have a quick look at the survey and try to, be as flexible as possible to adapt to your requests. So while everyone is filling out the survey, let me introduce myself a little bit. I am a sales engineer. Sales engineer is like a very unique role. It's like half sales, half engineer. So I'm the tech person for the sales team, and I'm the sales person for the tech team. So it's flexing two roles at the same time. Actually, I've been doing this for my whole professional career. I worked for like 10 years for software pre-sales, sales engineer role in one company, and 5 years ago I joined Google. And when I started in Google, I was more on Google Apps. So how many of you use Gmail? Thank you. Many people use Gmail, but Google Apps was about bringing that power of collaboration into organizations. And I started as a sales engineer in Google Apps. Eventually, I moved into the Google Geo team, which is Google Maps, Google Earth, again for larger organizations to adopt the Google technology that we've been releasing to consumers into organizations for the business applications, for the internal systems. And a couple of years back, I was leading a team in Japan, and I started to think about what's next, and I really wanted to invest myself more in the platform. And as the platform was emerging, I started to dedicate myself totally into the Google Cloud Platform. So now I am 100% dedicating my time for the Google Cloud Platform. And this event, the Google Cloud Platform GCP Next event, was the first time we had a pure Google Cloud Platform event. And this was held in San Francisco, and we want to expand the message from there to the audience worldwide. I find it also interesting because in the past I've been doing a lot of things. I started at university when I was studying doing image processing. I was doing like aerial image processing to detect changes between aerial images taken for the same place but in different years. It was difficult because the aerial, the equipment can be very different models, different lenses. It's hard to know how you can pre-process one photo to match the other. And in those days, I was using neural networks to do that kind of image processing. My master course, again, I was using neural networks, but now for content classification, I was like creating a search engine for like educational content so that I can pick a website and say this can be used for this topic of which grade. So that kind of mapping was done again using natural language processing and neural networks. In the first software that I was working on was like machine translation or voice recognition or text-to-speech. And then I eventually moved into more enterprise software. But using the Google Cloud Platform is interesting because all these things that I've been doing are now coming into one piece. Because machine learning, voice translation, all these things have now becoming a core part of the Google service that we offer. Okay, has everyone filled the form? You don't have to, but it would be helpful if you could. Let me have a quick look at some of the responses. Okay, so how about the GCP Next event itself? Let me make it a little bigger. Yes, so some have really attended the event. I envy you. And okay, the live stream not really, well, it wasn't really time friendly, so that I understand. Some have already looked at the content. Okay, and for some it was totally something you don't know. And I see that there's more developers here, researchers, data scientists, okay. And your experience with GCP seems to be really varying quite a bit. Machine learning, okay, this is interesting. We had this GCP extended event in Singapore last year, and at that point, it was like mostly no one really had experience, and it was like lots of zeros on exploding. Now it's, what is subscribe? Okay, so one source of information that many people don't know is that we now have a podcast for Google Cloud Platform. So if you didn't know that, you can subscribe to that on your phone. You can listen to that on your commute. Please do use that. Requests, Kubernetes, technical explanations, okay. 3D imagery. Okay, so thank you for the request. I wouldn't say I can cover them all in this session, but let me do my best. Okay, so those who don't know about the event, this was a 2-day event. The main event was a 2-day event that was held in San Francisco. The website is still up there. If you go to the agenda, you'll see that there was a keynote for the day, and there was like 3 tracks during the 2 days. And the breakout sessions were one was like application development, of course, is a big topic. Another big topic was infrastructure, virtual machines networking, containers, how you can migrate your current existing workloads to the cloud. Those were another topic. And data and analytics. Google itself is has a lot of data center. But what we do is really crunch the data to make meaningful insights out of it, to enhance the project, give you the insights, and all of that is done by the technologies that we have really invented, or the technologies that we have taken from the open source and put it into our infrastructure. So there are a lot of sessions about data and analytics, and we'll be touching a little bit more about those. There was also another category which was called Solutions Showcases, where we had a deep dive into some of the real customers' use cases. Some were more about financial time series data analysis. Some might be about a big data processing for, what was it? Well, there was many customers coming on board, along with our product teams, to really talk about their experience, what the architecture was. And I think it was a great sessions that we had here. For the two keynotes, if you look at the speakers, day one was 40 minutes. The keynote of day one, there was a lot of speakers, but it started from Sundar Pichai. He's the CEO of Google. Google has transformed from just Google to become a more alphabet company. The two founders are now on the alphabet level. Google is run by Sundar. Although he doesn't show on the webpage, maybe it was like last minute change. He was there. Diane Green, the new head that is leading all this cloud and apps business, was there. It was also to show our commitment to the enterprise business. Of course, we are providing a platform for startups, ventures, but we are getting more into larger organizations, and we are changing our structure of our organizations, how to well adapt to that market as well. And of course, the father of our data centers, us, was there. He is the one that owns our technical infrastructure team. And Jeff Dean. Who has heard about Jeff Dean? Is he a known person here? If you have heard about the Google technologies that we have invented, because there was no other technology out there that you can use, you might have heard about like Bigtable, GFS, right? All these, or MapReduce. All these things, I would say, he's involved. You give him an idea, you give him a code, he'll make it scale. And he's a great person. And what he's recently been working on is a project called Google Brain. Google Brain is a project that is about a common infrastructure inside Google so that we can easily adopt the best practices of machine learning, especially deep learning. And he's leading that, and he can talk about that as well. So going back to my slides, one of my favorite sessions was the keynote from Eric Schmidt. It's rare to have him on a conference, and I think all the attendees were delighted to have him. But it was the insightful talk that gave us about, he has been in this industry for long. Actually, he's been leading this. And he talks about the emergence of all these technologies and why now is the right time to get started with the cloud. And he talks it in a way that everything you do today, if you are, for example, an application developer, you might not really want to be hands-on on managing your networks, operating systems, virtual machines, patching them, keeping them up to date. What you want is a more abstracted layer where you can concentrate on your code, deploy it, make sure it runs, release it to people, make sure it doesn't go down. And there's been this abstraction that everyone has been working on. And the early adopters have been taking these technologies like App Engine from the early days, or we're also having like containers and all these stuff that enables workloads that haven't been able to get that abstraction, also to move to the cloud. Also live nicely together with a hybrid model. And with this all coming in, it says now is the right time. I highly recommend going through this video. And the other nice thing about his session is that he's a chairman, right? But he gives like 10 things to do, a to-do list, 10 things to start with at the end of the session. And the 10 things are like nothing that a normal chairman would give you. Start with a modern programming language like Go, or like use App Engine or containers. If you want to choose operating system, use Linux. Use gRPC, start with machine learning, don't take it lightly. And all these things that were given from him as what are some of the things that you might want to invest more of your time in. So, whenever you have time, please have a look at it. The great thing is that all this content is now on YouTube. And if you go to the Google Cloud Platform channel, all of the sessions are recorded and there for you. In this session, instead of just replicating some of the sessions, with the limited time, I didn't think that's really possible to cover everything. So I've decided to focus a little bit more on one theme that has been more and more highlighted, and I get a lot more, inquiries of, how I can use this as part of my service, as part of my strategy, and that is machine learning. So in this session, I'll be talking a little bit about how we're using machine learning, what's out there, what kind of offerings that we provide today, and how you can approach your strategy for machine learning, and also how you can get started. Is that okay? Would it be a topic of interest? Yes. Okay, thank you. So, in GCP Next, machine learning was mainly talked in these sessions. The keynote by Eric and Jeff Dean, again, talked about Google Brain. And there was following 2 sessions that really dived into how to implement or what the actual use case would be. So I'll be talking about these. And first of all, I'd like to share with you this talk from Eric on machine learning, because it really resonated.
This cloud platform we're building will abstract out all of those examples like the choke. And what it will do is it will give you a platform that you can really express. And it's timed, and the reason it's so important to me is that it's timed perfectly for what's going to happen next. And you're going to hear a little bit about this in a minute from a couple of other people. This platform is not the end, it's the bottom. And there's something above it. And the thing that is above it is machine learning, both narrow AI, as it's called, as well as general AI. And this is the next transformation. I've decided to spend as much time as I can on it because I think it's so profound. And it changes, I'm basically a programmer who sort of got lucky, if you will, in Google. And the programming paradigm changes. Instead of programming a computer, you teach a computer to learn something and it does what you want. It's a fundamental change in programming. And we've just taken the initial steps. The neatest examples that most people can understand about machine learning are involving vision. So we built a library called VisionML, which we have announced, which will be demoed today. VisionML does the classification of photos, right? It's great fun. And if you get confused over why this is so important, use Google Photos. Spend a little bit of time playing with Google Photos. It's not the fact that it uploads it to the cloud. It's not the fact that it does face recognition, all of which used to be amazing. It's the fact that it then classifies all your photos into what you're doing in them, and how it does that is beyond me, right? I literally still don't understand. But perhaps the greatest example is what happened in Korea a week ago with AlphaGo. AlphaGo, as most of you probably, Go is the hardest game known, incomputable in its traditional, And the team invented neural networks, of which there were two, a value network and a policy network, that could be used to learn how to play the game. So the most interesting thing about AlphaGo was not that they were brilliant people and brilliant programmers, but that they had to design as part of their software learning algorithms that were tailored to the way the game actually worked. And that's the next layer. It's the layer above. And 20 years from now, people will say, remember the choke? And then they'll say, yeah, in 2016, yeah, we had all those VMs and all that other stuff. We don't think about that anymore. But somebody took care of it, and now all we're doing is doing various forms of learning, cognition, and modification, improving the code. So how do I translate this today? So I figured I would offer sort of, and put this in perspective and finish up by saying, I think there's 10 things that you all can do right now. Obviously, thank you all.
Also clear, but you heard it, right? What you do today is important, especially, well, many of you are developers. Many of you might not be thinking about migration and more concentrating on development already. But still, many of you, I think, are concentrating on the infrastructure, getting things right. That's important. But Eric started with what's next. What you're doing today is still the beginning. And what next is after you have the infrastructure, run applications, collect the data, store it, process it, what are you going to do with it? And the fundamental difference between what the typical data processing used to be and how it just changed with machine learning is moving from just rule-based, saying, okay, I find something that looks like a face because I know faces are structured this way. And then, so this is probably the eye, this is probably the left edge of the right eye. You can do that, but that's more rule-based, or turning your knowledge into algorithms. But moving from there to say, okay, I know this is a photo of an image, photo of a face. Okay. These are faces, these are faces, these are faces. You throw tons of data into a model and let them learn. And now you have a model where you can input new data and get the outcome. So this paradigm shift is something that you have to learn, and you have to keep in mind that it's something different. And it is actually what's next. So again, this one is highly recommended. Please go look at Eric's session if you have time. And then Jeff Dean. So Jeff Dean, being the father of all these technologies that we run at scale, is now running the Google Brain project. And one of his slides shows how in Google we are really adopting these technologies more and more and more. And you see this acceleration, right? And some are probably obvious, like the AlphaGo, it was obviously using machine learning or deep learning. Some things in apps. How many of you use Inbox on the mobile? For those who don't know, there's a Gmail client and there's an Inbox client. Yeah.
Inbox.
So, and one of the features is auto-reply, or it will give you like 3 buttons at the end of the email and showing, is this the reply that you want to send to? That kind of application is using deep learning. The Google Photos is another obvious one. Speech recognition, translate. There's a lot more actually. We Google, when we run operations of a data center, we use machine learning. So there's a research paper out there if you're interested. But if there's data, and if there's so many parameters that you don't know what the rule is, you let the machine learn. And then you get some insights, and then you get some ways to notice what you might want to change to get a better outcome. And we run our data centers with machine learning so that we can be highly optimal and become more of a complete data center operator. Okay, so when it comes to machine learning, there's 2 types of offerings that we have. And this is one of the categories. This is something that you can just easily start with. just APIs. I would say these are machine learning powered APIs. Okay. So one of the APIs that has been there for long is Translate API. The Translate is simple, right? You give a text in one language, say it's in English, and say you want it in some other language, in Chinese or Japanese. It's text in, text out. You don't really have to know about machine learning, but under the hood in the data center, it's using machine learning. Okay? So this is different. Using machine learning, for some of you, it might be going into really building the model. But for some of you, you don't really need it. All you want to do is just use it. And these APIs are the APIs that you can get started with. So Translate, I think many of you can just easily know what it is. If you use Google Translate, this is the backend that we're exposing that is also powering Google Translate. Okay? I'll just skip the middle for now. Google Vision API. There's a hands-on session this afternoon for this one, so that if you are interested in how to get it run, please go there. I can give you a quick demo also, but Vision API is an API that is powering services like Google Photos. You give it an image, and as a result, you get what's in the image. How many faces are there? Is that person happy? Which location or which landmark is this representing? Okay. You don't have to need to know about machine learning, but you can use it. More details are coming. And another one is Predictions API. For some of you, you know you have data. You've been collecting data, right? It can be logs, it can be some user surveys, it can be anything. You want to make something out of it. You want to use it to predict something. You want to use it to classify new data coming in. But you don't know data science. You don't know machine learning. What would you do? Prediction API. So this is an API for application developers that know nothing about data science, for you to dump in the data and let Google figure out what model to adapt to that data. And then your data turns into an API wrapping a model that is generated in the cloud. Okay. So if you have data, you want to do something, don't know how, this is where to go. Until you learn how to do things more at a sophisticated level. This is actually more of what the Vision API can do. It is just GA, so it's no longer beta, it's no longer alpha. You can use it, you can pay for it as well, so that you can use it for large scale. But if you have a collection of photos that you want to make out some meaning, not just the tags in the photos, right? The cameras will give you lat long, or sometimes give you more image properties about the photo. But if you have a lot of data, human can get more out of it. Why? Because human can tell what's in the photo. It's hard to code a program to do that, but by using this, you can do this. We also announced a new API in this category, which is called Speech API. I ask this question, and I always get a different response depending on the profile of the audience. But how many of you search Google using your voice? Great. I mean, in general, the higher generation will say, I haven't done it before. The younger it is, it's more natural. My kids will just use voice all the time, right? But so the voice recognition has been there as part of the Google services for long. It's been using in the Android. There's a web speech API that also hits the same backend. But now we have decided to expose this as well as another API. So imagine having a lot of recordings. Right? You want to transcribe that recording into text. Now what you can do? You can search through recordings, right? If you have used YouTube and know what it does, you get an idea of what this API can bring. So turning audio into text is what this API does. And what Jeff followed with that was TensorFlow. So those of you who have mentioned that you have experience in machine learning or data science are probably those who have been coding in Python or using tools like R. It's not Excel, right? It's if you really want to do it at scale, it's not like in a spreadsheet. It's more in these machine learning libraries. We didn't actually adopt things like scikit-learn and these libraries. We came up with our own. And the reason is, creating a library probably is not too hard. But when you want to really have something that can scale, it is hard. So TensorFlow is an open source SDK that comes from the Google Brain team. So you saw the acceleration of Google's adoption of machine learning. Why that could happen was, in Google, we provided an SDK to each of our product teams so that they can easily code in a way that they can adopt a machine learning. And that SDK is the core of what is now called TensorFlow SDK. Okay? So I don't know if many of you know that understand the notion of tensors. Let's say it's a vector matrix. But all the calculation can be expressed as a flow of these tensors. And this TensorFlow SDK is easiest writing those kind of algorithms. It being an open source project, there's lots of interesting things that have happened. It's not only Google using it, a lot of developers have used it. Oh, this is one of the examples, but if you go to GitHub, there's like already hundreds of projects that are using TensorFlow. It's really, really amazing to see what effect it causes. Google usually, or in the past, wasn't really that much an open source company. Right? We might be adopting it, but we weren't contributing that much, or taking out up points of making it open source. But we're doing this, we're shifting gears a little bit. But doing this, we're seeing lots of adoption. And this is not by Google, but from one of those projects that they built a model that learns the painter's, the way they stroke, choose the colors. Right? Now they have that model, they can inject the new data and get an output. So the new data, in this case, is this photo. And by copying the way that painter paints, came out that photo. Okay. So I think it's there's a new category of like machine-generated art, machine-generated poems, machine-generated whatever. But it's interesting to see that, and yeah, please try it out. It's open source. It's on GitHub. Google did something similar with called Deep Dreams. I wouldn't show it up because when you search for it, there's lots of images that may not be appropriate here. So I wouldn't bring it up, but Deep Dream is a result of a machine learning model trying to make sense of an image, right? And say, okay, I think this can be looking like an eye of a dog. Okay. Then if you tweaks the images a little bit like a dog and go through the same process again and again and again. And then, as a result, the original images is going to morph into like a really a collection of birds and dogs. And please search for it. It's easier to see it and explain. So TensorFlow is great. Now it's open source. You can use it anywhere. But it doesn't stop there. We announced the Google Machine Learning, Google Cloud Machine Learning. And what this does is take what you have built and give a runtime on Google. So machine learning, for those who know, what's the most expensive part? It's probably the learning process. Okay. The learning process is, once you design a model, you feed in the training data, you get the output of the training data, and you see that it's not the expected outcome, and then you start adjusting the parameters in this network. And you go over the loop over and over again so that the input will be producing a good output. And when the output, and when the difference or the evaluation result is low enough, you consider this network, well trained, ready to go. And this training process is really hard to do at scale. If you have terabytes of data and you want to run it, if you can wait for months, fine. But it's really hard to do that large amount of processing in your machines, in your data center. You can do it, but then you have to think about how I can maintain the infrastructure to run that training. So Google Cloud Machine Learning is a runtime in Google that we maintain. We power with like GPUs and all these things so that we can get a boost of this training process. And once the training is done, you can take out the model or take out the parameters that are tuned, and you can run it elsewhere. Okay? So using the machine learning model is not the heavy part. The training is the heavy part. And this especially helps with the training. You can use it as actual using part as well. But the uplift of the training process is going to be the key things. Jim also talked about how faster it can be. And this is a chart. I know it's a little bit too slow. But it's like the blue line here is what it takes if you did this training on your own machine. And the orange line is what it can be when you run it in the Google Cloud Machine Learning service. It's like a 20x acceleration. Think about what you can do with this fast machine learning process. You can have like a daily model, update, which is not possible if you just try to do it on your own infrastructure. Okay, so that was from the keynote. And one other session I'm going to introduce a little bit was from Julia, who is one of our developer advocates. And she also took this session with a person from Wix, and he was adopting the vision API. So how many of you have asked this question to yourself? You look at something and say, can I have this? So that was Julia's question. And the challenge was, can I implement a model that helps you detect if something safe to have? So, on the left side you see a fluffy, what is it? Is it a rabbit or? And on the right side you see the glass object. It's obvious for human which is safe, which is not. So, again, the details, this session is not enough to go into too much of details. The recording is all there on YouTube. But just to give you an idea, she had a collection of photos that she labeled. Labeled means, okay, this is a broken glass, this is unsafe. This is a doll, this is safe. This is a pillow, this is safe. She had a collection of these data that she used to train her model. The model was written in TensorFlow, you gave the input, go over the iteration of training, and then you get a model. Once you get a model, you can give it new data and see the outcome. So the interesting thing is that this is the left one. Okay. She gave a new data of an octopus. Is this huggable or not? I would say not huggable. Some people may say it can be hugged, but yeah, the model returned not huggable. On the right side, that's an octopus too, but that was returned as safe to hug. So I mean, even in her words, it was a different implementation of the same thing, which is a technical word. But it's interesting that once you have a model that has learned, you can detect from like the surface, the texture, what material is made for, even if it can be having some similar structures, what is huggable and what is not. So whether this huggable or not engine is going to be useful for you, I don't know. But it's just to get an idea of what you can implement when you have data. Wix, this is interesting because this is for the other side of the audience. which is Wix is everyone knows Wix, or have you used it? It's a website that allows you to easily create intuitive websites. Right? So there's lots of widgets and all these things that you can choose from and make your own website. They have tons of products. And what they wanted to do was know what the user is trying to do, help the users more and more, so that it's easy, the user experience is much better. You can get to the website that you want in a shorter time. You can get to the right content. But they didn't want to ask too many questions to the end user. So what they did was they have a big collection of data. And they used the Vision API to extract more meta information of these. So, and they tagged that, they recorded that tag into a system, so that not only from the attribution that the user had added to it, but they also used the information that was returned from a Vision API to group content together. So if you search for San Francisco, for example, you can search for content that can be related to San Francisco, which can be from buildings, because Vision API can detect major landmarks in a photo, for example. So those things that are really hard to do without knowing machine learning, but because of these APIs, you can really just do it if you can write code. Okay? So this is a great example where an application developer, not knowing anything about machine learning, can still use machine learning. And if you have a portal, if you let users upload content, these vision and speech, and will help you get more information out of these bytes that human can do, but it's hard to do with the code. Okay, next I want to move a little bit into, what can I do if you really want to get into the machine learning space? Again, it's really a spectrum of services. It's not a single answer that is for everyone. First you need to know which side of the machine learning offering that is going to be for now. For me, may or may not be for now, maybe for the future. But on one side, again, we have APIs that anyone can just use. If you can write code, if you can make a REST API call, you can use it. Okay. The other side is, I stated as academic or researchers or data scientists, but if you really know what you want to do, if you know the algorithms, if you know what model or what kind of research papers that you want to bring into implementation, that's the other side of the spectrum. So then you want to go into TensorFlow. Okay. So let me give you a little bit of an introduction on how you can use the first category. Right? So translate, vision, speech. Out of these, I'll just quickly go to some of the vision examples. You can have a code lab, so you can try it yourself. But this is a Python code. This is actually an example, a modified version of the example provided in the Vision API documentation page. But it's simple. What you do is, there's two ways to do it. One is embed your image into a request. And the request could be something like this. What I'm doing here is, I'm creating the JSON object that I'm going to send as a request. And as part of it, I have an image. And the content is going to be a base64 encoded image. So the larger the file, it's going to be big, but all you do is just send it out. And at the same time, you're going to say, what's the kind of image processing or image content extraction that you want? And you can choose from different types. And you can also make multiple types in a single call. So label detection is detecting what's in the photo. So if I take a photo here and run it, it'll probably say like auditorium or conference, people, face detection. This is like how many faces or where is the face in this photo. Can anyone tell me what's the difference of face detection and face recognition?
When you detect a face, you just know, like, that's a face. But recognition, like when you show the exact person, like who the person is.
Yes. So it's what we provide here is face detection. So we'll tell you where in the photo, where in this bounding block a face is. We even get you more granular input, like where the eyes is, where the nose is. You also gave you an example at the moment. But we don't do face recognition. We don't map that person's face to an identifiable profile. Okay? For security reasons, we don't want to do that. Okay? So that's something important to know. If you want to do something more, you might have to implement something yourself. Okay? Text detection is OCR. So if you have an image or my t-shirt says Google Cloud Platform, you give a photo to this API, it will return this text. Of course, it can't be perfect. If you look at the logos of all your t-shirts, I mean, some are really hard even for humans, right? So don't expect this to be perfect, but it's important that you test it yourself, see the quality, and find out if that's a level, at accuracy level, that makes sense for your use case. Logo detection. So famous brands like Starbucks, McDonald's, if you give it a logo, it can detect the logo. And landmarks is like Eiffel Tower, Again, this is not a complete database of the world, but we try to do our best to detect like major landmarks that are out there. So it's not just about returning Eiffel Tower as Eiffel Tower. It could also return the landmark, because in Google we have the geodatabase and say, okay, this landmark is positioned here. Why not return the location of that too? So I've seen examples where you can't really rely on the EXIF metadata a camera gives you, but you can use this API to embed more information into photo. Okay. Safe search is another example that is really hard to implement yourself. If you own a website and if you're hosting content and serving it to users, you don't want inappropriate content to be there. There needs to be a better way to filter that out. I mean, Google, you don't see those not really good images in Google sites. We filter that out, right? In YouTube, we try our best to filter out inappropriate content. So that algorithm is also being hidden behind this API, so that it can return results like, this is likely to be inappropriate. We give you a score, so you can set your own bar. How safe, how completely safe you want it to be. If it's content for children, you might want to set the bar higher, or you might be okay to set it lower. Okay? And image properties is more about predominant colors and stuff. So this is an image that I have for. Okay, this is a profile image that I have on some of my social networks, and this is the result that came back. I think I have a better way of showing this to you. Yeah. So by using the Vision API's face detection, it will give you a bounding box of where the face is, the central and the outer bounding box. So this is an example by combining this API with OpenCV to manipulate the image and draw bounding box on top of the image. But if you look at the face, you'll see more red dots. I'm not perfect at UX design. So there's probably a better way to do that. But you can see that it detects where the eyes start and stop, right? Where the nose is, where the eyebrow is. All this information will be returned to you as part of the JSON object. Okay? What you do with this is up to you. So if you are to implement a makeup application, now you know where the ears are, where the eyes are. You can add some color effects on top of a photo, for example. This is another photo that I used, which is, this is spherical. You know, there's 360 cameras these days, image, but I want you to try if it works fine with like many people. Sorry, the resolution is not really good, but for every people, oops, you can see that for multiple people, multiple results are going to be returned. You can say how many people are there, but you can go beyond that, right? And it also returns information like how happy you are. You know, this guy is obviously happy. It's easy as a human to know that. But the good thing is that now you can use it as part of your implementation. You don't have to know what a happy face looks like. It will just return you, this person is likely to be happy. Okay? Okay, so that was more about the easy APIs that you can use today. I have an example for speech as well. Speech is now in the limited alpha. You have to sign up for that. I'll just show you a result, what it can look like. I just downloaded an MP3 file from one of the podcasts. MP3 is not the audio format that we support today, so I converted it to FLAC, which is like an open and lossless compressed algorithm. So I converted it, and again, just like Vision API, I encoded it, posted it to the backend, and it returns the text. Okay. How powerful is that? So it gives you with the confidence level. Sometimes it's not really high. Sometimes it can be many people speaking at the same time, having a lot of background noise. Background noise is generally okay, but please try it out if you're interested, and you can get the text out of the audio. And maybe you can use it as part of, I don't know, conference meeting recordings, so that you can help you with generating meeting notes. I don't know. It's your imagination on how to use this. Well, we are providing a way to turn audio into text, and it's there. Okay, going back. Okay, so now I'm going to talk a little bit about the other side. TensorFlow, if you really want to know about it, this is what it looks like. It's a Python-based SDK that allows you to express your tensor to tensor flow. That's where the name comes from, effectively. And once you have that, you can express the calculation you want in a code like this. I wouldn't go into details. If you want to go to the details, there's a great tutorial on the tensorflow.org website. One thing I want to mention is that it runs anywhere. It runs on a Mac, runs on a server like this. There's a server here. You can run it back there. You can run it on the servers. You know, run it on your on-prem data centers if you want. They come up with a TensorFlow distributed version. You have to do the configuration. You can leverage the GPUs as well. Unfortunately, not on Mac yet, but if it's on the servers, you can do that. And it can also run by using GPUs on mobile devices. So imagine doing the learning process in the cloud, taking out the model, now at the phase of actually using it, you put the model into your mobile application. You can use the GPUs in the mobile application to run it fast, and then you can do things offline. Right? I'll just skip these. Cloud machine learning, we announced it, but this is still in alpha, private alpha. If you have a strong reason that you really want to touch in this alpha phase, let us know. It's really limited at the moment. Eventually it will turn into beta or public beta, and then everyone will try it out. But please do let us know if you really want to try this. One thing I wanted to touch here was that I talked about TensorFlow SDK, also about machine learning. But when it comes to machine learning, it really is critical for you to be able to have enough data. Right? So some people try to go straight to machine learning, but actually without solving the big data problem. You might want to be prepared for that. So you can use our cloud storage to store tons of data. Forget about losing data. Forget about removing data just because it doesn't fit in your disk. Disk storage is now really cheap. So use the storage in the cloud to keep your data. You don't know what you can make out of your data today, but it can be really valuable in the future. So unless there's a reason, don't lose data. If you just want to quickly scan through the data, we have services like BigQuery. I wouldn't go into details today. If you want to interact with the data using Python code, we have an IPython notebook for Jupyter implementation on Google, which is called Google Cloud Data Lab. So if you're a data scientist and are really used to using those tools, please try out Data Lab. Data Lab, for those who don't know about it, it's like a big data powered wiki. Okay? It's a wiki site that you can write your sentences, your content, but you can also write your code and you can run the code in that page. Okay? So if you say if you have a hypothesis, you can say this is what I think, this is what I want to try, put in the code, put in a Python code, a SQL code, run it there, visualize it in that page, and say, okay, I have proven that it seems to be okay for this part, but maybe not for this part. Therefore, I want to tweak my code, and next time I'm going to try to do this. So the thought process can be all captured into this data lab page, and that also can be integrated with TensorFlow. So data scientists out there, please try it out. It's beta still, but it's totally usable. So for you, I really encourage you to think about today, if you think machine learning is something that you're going to be using in the near term or mid-term or long-term future, what machine learning approach should I take? Okay. Is that going to be your core skill, or maybe a business even? Are you going to be the consultant for that? Are you going to help people adopt machine learning? Or is it that you just want to write an application we can adopt these Google magic? Okay. And it can be somewhere in between as well. Okay. If you don't know if you're prepared for data science, there's this tutorial on the Google Cloud Platform Solutions page, which is called Machine Learning with Financial Time Series Data. Okay. This goes through a 7-minute video, there's a 20-minute version too, of what one of our data scientists did to collect data, pre-process that, and then apply machine learning. On the pre-process part, you will learn what it actually takes to make a meaningful data or high-quality data. And if you see this, you're probably able to tell if I'm ready for it or not. If you're ready, go do it. If you're not, learn or get someone's help. And that help will come from someone in this room, in the community, and if you want to find someone, we can also help you and connect you with us. If you don't know neural networks, don't know deep learning, go to TensorFlow's playground. It's a great tool. Conscious of time, I wouldn't spend too much, but this is an example. This is a live page. It's running in the cloud browser, but say your data looks like this on the right side. Okay? You want to create a model to classify these dots. As a human, again, it's easy. As a machine, it's not. So what's the kind of model that I can build to actually learn how I can set the boundaries to classify these two groups? Okay. If you don't know neural networks, this is a great tool that you can say, okay, what effect you can get by adding more layers, more nodes, or different algorithms, and you can see it visually. Right? And you'll see how the learning curves can go down quickly, or it can take time. Treat these, it will give you a great visual, because these tools didn't used to have a visual. It was hard in the past. Now you have these. Please use this. And once you get the basics, go to the tutorials, and at last, please go to some online courses as well. What I highly recommend is Yasuki's course, because they have a really sophisticated course. It can be for general data science, but it also has some courses built by Google, which are touching more into deep learning. And this one is one of our data, researchers in Google doing the course. And Udacity happens to be founded by a person who used to be in Google X. Sebastian here, who is actually teaching here, is the founder, and he's a person that used to be designing the algorithms for self-driving cars in Google using machine learning. So he's an expert, and he's here to help you with this problem. Okay, so that's what I wanted to introduce you today. I know for you, some of you, it wasn't technical enough. Maybe you want more, then hands-on for you. There's tutorials for you. But I think it's your turn to decide what to do with machine learning. It's going to be a hot topic for quite a long time, I think. And getting there is not easy. So you can start preparing today, or at least set some strategies, so please do that. For those of you who haven't really started with Google Cloud Platform yet, there's a great $300 worth credit for the user. So if you sign up for the Google Cloud Platform, you can get $300 to spend. Okay? You still need a credit card, you have to do that. But with $300, you can do a lot. It doesn't matter what APIs you try. You can use it for App Engine, the platform as a service. You can use it for compute nodes, virtual machines. You can use it for containers. You can use it for these APIs as well. Okay? So if you once you identify what you're interested in, please play around with it. Your technical audience, the only way to get to it is by actually using it, and we want to support you with this. Okay, with that, my session comes to the end. If you don't mind, I have another QR code here, and then if I can get feedback, I'd love to get some. And if you don't mind, and if you can leave some contacts here, our team in Singapore can also reach out to you and sending out more updates. Yeah. So if you don't mind, please fill this survey. Okay, that's all from me. Thank you very much for listening. You go ahead. Okay, the next session.
Alright, thank you again to Mr. Noya. Right, a very good morning to everyone. I'll be your MC today, Ashwin. Okay, you can address me as Raj as well. Alright, before we proceed to our next session, I'd just like to share a few details with you. Starting off,
single person will create 100,000 accounts just to get the $300 free credits. So it is for free. You get $300 free credits. You just have to input your credit card or debit card details. Now, if you don't have a credit card or debit card, I encourage you to get one. I don't know if in Malaysia they have this, but in the Philippines you can actually get a debit card for only 30 Malaysian rupees. So the equivalent 30 Malaysian rupees. You fill up a form online, one of our banks, and then you fill up the details. There's no approval process, and then you just walk into the bank, pay 30 rupees, and then you have a debit card already. Of course, you have to load it up first, and then you eventually have it. I don't know if you had that in Malaysia. Do you have something like that?
Used to have.
Used to have.
Yeah.
They move backwards?
I don't know.
It's supposed to be progress, right? Okay, but if you don't have one, I encourage you to get one. You know, if you're serious about software development, this is the online world. This is our job. We need to have an online account, and this is how we pay things for now. Unfortunately, they don't accept Bitcoin yet. So, if you're into that, you need a credit card still. So go create a project. And then yes, agree to the terms, read it, if you're into that. It feels like I'm in a storm, right? Over here, reporting from the eye of the storm. It is so cold, I am freezing. Okay, so the Google Cloud Platform is huge. There are a lot of products, there are a lot of services. In fact, let me just show that to you. So if you go to cloud.google.com, and then you click on products, these are all the products and services that Google Cloud has. So you have Compute Engine, you have App Engine, Container Engine, you have the storage, you have cloud storage, it's like S3, nearlines like Glacier, Cloud SQL's managed or managed database, Cloud Data Store, NoSQL, you have Bigtable, I haven't tried that but it sounds really good. Networking products, you have big data for big data, and then machine learning. And so we're going to study Vision API today, so that's just one. But before we can do that, we have to enable it. So let me walk that through. So you go to cloud.google.com, I go to my console, I create a project. So the first thing you have to do there is just click here, then create a project. This is not yet launched, please don't share it. Okay, let's call it Cloud Vision KL. Alright, we got that. Create. And it is creating, ladies and gentlemen. It is over here. Let's see how fast Google can create that project. It is spinning up resources in all corners of the world, in several data centers, all at the same time. And ta-da! We have it! Even less than a minute. We're pulling up our project, and the first thing we have to do is to enable the Vision API. Now the good thing about Google, it does search very well. You just type Vision, and then ta-da! Cloud Vision API. So you click on that. The first thing we're going to do is we're going to enable it. So by default, it is not enabled. So we click Enable. Just so that I know, how many of you are actually in this page and didn't get stuck in the credit card part?
Yeah.
You're in this page?
I'm in the credit card now.
You're in the credit card. Okay, so now you're watching this. So don't worry, you'll get back during the coding session. I'll give you an API key. It's in the document that you can copy and use. Okay? Alright, so then I'm just going to show you then. This is a demo of how you'll actually do it if you got to the credit card page. So you enable, and enabling is very easy. It's just pressing a button, and it gives you that really nice loader telling you it's enabling. Now behind the scenes something is happening, and ta-da! We are now enabled. Yay! So we then click credentials over here, or you can go to credentials. And it asks you, find out what kind of credentials you need. So I already know what kind of credentials I need. I'm going to get an API key so I can do a browser-based implementation. So let me just skip that. And then create credentials. So API key, OAuth client ID, and service account key. So the service account key is very interesting because it allows you to do like within the Google Cloud Platform like credentials space, so that any other products and services within the Google Cloud Platform can access the Cloud Vision API without having to do so much more additional authentication. But for this, we'll use the API key. It's a very simple one. We want a browser key. Okay. So the thing with the browser key is that for demo, deactivate later. That's a reminder for me so that you don't spam. And then you can whitelist the servers or domains that can call this API key so that in case, because it's in the browser, other people can see it. And if they can see it, they can steal it. But because of this, you can whitelist the domains so that it will work on other domains and only on your website. So we'll just leave it blank so that everybody can use it. Create. Ta-da! And here is my API key. Yay! I'll copy that. Okay. And then let's put it in the document. So we did that. We did the Cloud Vision API. We pressed enable. We pressed enable. We went to credentials. We pressed create credentials. We chose API key. We chose browser key. There. This is now the generated API key, but we'll replace this one with our, whoa. There you go. So this is the new API key. Let me check. It ends in Q. That ends in Q. Perfect. So we now have our API key for this demo. So now this is where everybody joins in. All right. So first we create a folder in our computer and we call it Pokédex. Ta-da! So I'm going to put it here in projects. Let me just do that. And then I'm going to create a new folder. And we'll call it Pokédex. Enter. And then what we're going to do is we're going to open our preferred text editor and enter the following text. Okay, so I use Sublime. Just let me open this up in Sublime. Okay, make that big. Pokédex. And then let's open this folder in Sublime. Alright, so I have here, and then I'm gonna enter the following text. Now, we can type this, or I can do what every programmer does, which is copy, and then paste. Yay! You know, when I started programming, there was no really internet back then. 1998 Google was just invented. We actually studied using books, and we opened the books, and we read the sample code, and we actually copied that sample code, like from the book, and like typed it. So those missing semicolons, missing things, they actually happen. Today we're so lucky. We just go to Stack Overflow, copy, Control C, Control V, Control S. Teacher, I'm done. Yay! So what do we call this? We'll put it in index.html. So let's put it in our Pokédex, and then let's call it index.html. Now, what is this? What is this code? It's very simple. We're just saying this is an HTML5 document. Just so that I know, who here is not familiar with HTML? Raise your hand. Perfect. Yay. JavaScript. You're not familiar? All right. Don't worry. Just ask us later. CSS. Okay, great. So 99.99%, just like the availability commitment of the Google Cloud Platform. 99.95% actually. All right. So we have here our title Pokédex, and we have input type file. So to have our Pokédex, what we want to do is we want to create a way for the user to input data into our Pokédex. So this could be the photo that we're asking for. So the photo comes in the form of a file. So we have type file. So let's save that, and let's open it. So let's open. Ta-da! You know what, guys? I think so I actually play music all the time, especially when we get into milestones. So we now have our first working screen. This deserves a round of applause, guys. No, you know, programming is hard. Programming is difficult. You know, you have to celebrate every single milestone to keep your sanity, you know? Or else you'll be like, oh, this doesn't work. So when it works, celebrate, all right? When it doesn't work, go to sleep. When you wake up, you're probably like, huh? Why does it work now? I don't even know what I changed. Okay, so we now have a file chooser. We open it, and let's get some pictures in here. For example, let's put in this picture of a cat. Open. Ta-da! Well, that's not really great, because right now we just have, it doesn't work very well. So we have no file, it puts it in there, but does nothing. So what we should do next is maybe what we should do is get it to preview. So when we choose a file, it should automatically preview in the browser what the file is, if it's an image, and it will show the image, just like a true Pokédex. Okay, so let's revise our code. So we have to add more code. We'll add some CSS to make it look pretty, and we'll add this preview function. So we could type this up, or like every good programmer, whoops, not so good programmer, I could copy and paste this thing. So I copy this and I paste it. But let's go through this one by one. So what is happening? So first we added this meta viewport tag. This is because we plan to use our Pokédex in the mobile device. So we take picture with the mobile device and it will then return it what it is. So we'll use it mobile, not on desktop. Whoops. Okay. So this will make it look nice on mobile. And then we'll add some standard CSS here. We'll increase the font size. We'll change it to color blue. Just a caveat, I am not a good designer. So it will not look amazing. And then we just put some standard so it won't look really broken. Okay. And then what we will add here is when on the input tag, when the file is changed, so when we add a file or we select a file, we will trigger a preview file function. What does the preview file function do? It previews the file. But what does it do behind the scenes? Alright, so it's a JavaScript file. It's a JavaScript function that runs this code. So what does this do? So first, we will get our preview element, which is the image element. Let's find out, where is that? It's over here. This is the image element. We only have one image element, so we don't need to specify an ID. So we select it, so that's our preview target. That's where we will put the preview image. And then we will have the file element, which is basically our input, so which is this. And then we will instantiate a file reader. Now file reader, for those, this is actually a function in JavaScript or HTML5 that lets you read a file. So we put in the reader, and then the way JavaScript is written is like, it's weird because you do the stuff that you will do later and you define them ahead. But when we load something on the reader, we will basically then set the preview target element, which is this one, and we will set the contents of the reader. Okay, so when there is a file, the reader will read it as data URL and file. Now what is this data URL? This data URL is the base 64 encoded details of the file. Okay, so we can even we can log this. So for example, we can log this. Where do we log it? Here. Console.log image and then reader.result. We save that. So basically what this file does is that when we change the file, we put in something there, it will then put it in the image and as a source. So preview.src. Let's see if this works. Whoops, it's not registered. Don't worry, sometimes it's actually free. I didn't pirate it. It's a good thing they did that, right? Okay, so we then refresh this. See, it looks better. It's now color blue. And this is now the image preview section. So our image should appear here if I select something. So we choose a file, we choose the cat again, and ta-da! Ladies and gentlemen, it works. Yeah, right. Very good. You see that cat? It's not too happy. Not impressed. Alright, so we can also use another file. You can chat. Maybe this one is better. Oh, there. That one's cuter. Oh, let me. Okay, that's cuter. Alright, but what is the data URL? So let's go to our console. And this is the image file. So this is the base64 encoded version. Whoops, zoomed that too much. This is the base64 encoded version of the data URL of the image. So this cat, when you look at it in base64, looks like this. Not too pretty. but the machine can understand. Now, why is this relevant? This is great because we can use it for two things. One, we can use it for displaying the image in a preview, and at the same time, we can send it to the Cloud Vision API. The Cloud Vision API supports two formats. The first format that you can send it to, or the first input that you can send it, is a link into Google Cloud Storage. So you have to have the image in Google Cloud Storage, and then you can send it to Google Cloud Vision API. That's great because then it's on the same platform. The speed is very fast. That's great. But it's very difficult for me to demo because I have to upload it to cloud storage and then set up. So we'll be mixing up too many technologies at the same time. So we can also send it a base64 encoded string that is actually an image. So this is great because then we can use it. All right. So we go to the next step. All right. So the next step, it's the cat. We want to identify. This is the part where we throw it to the Cloud Vision API. So we're adding a few things. So first, we're going to add a results element. So it's just a div. We're going to put results, and that's where we're going to show what the Google Cloud Vision API throws us back. And then in the load function, aside from just showing the preview, we're also going to send it to the vision function. The vision function, I just made this. This is not like an SDK or something. But just to let you know, it's very easy to use. So the vision function, now the vision function simply assembles the URL, adds the API key, and then prepares the payload, which is basically saying requests, and then the features that I request, which is currently labeled detection. We can add more later. And then the image, and then the content is the string that was passed over here, which is the base64 encoded image. And then we're going to query selector the results div, and we're going to say sending while we're sending it. And finally, we're going to send it using the post method to the URL as application.json, and then the data type is JSON, and then we're going to send over the payload. And then when it's done, we're just going to record in our console what the response was in the data. And then we're going to iterate over it. This is basically just a function that makes it look pretty because it's like a whole nested JSON list. So we extract the label annotations and we push it to a description list variable. We push both the name and the score. The score is like the level of certainty that the Vision API thinks what the object is. So it can say like, I'm 99% sure this is a cat, or maybe I'm 50% sure this is a carpet. So, and then no responses if there's nothing that was returned. And then this basically just outputs it as a formatted, div, which is HTML stuff. Now, of course, this is not the right way to do it because I'm putting myself here as prone to injection. But if you're doing this production system, just make sure that you're doing the necessary security measures. And then finally, we're going to insert the formatted HTML stuff, great variable names, into the results inner HTML. And then we should be done. It should work. So let's copy that. Ta-dun, 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 ta-dun. Whoops. Ta-dun. Copy. And then paste. Let me just replace one thing. What should we replace here?
API key.
Perfect. Very great. So we just remove the API key and I'm going to replace it with the one that we have. Oh, where's that? Over here. Save that. And we are now going to refresh it. Refresh. Choose file. And then let's choose this one still. Let's see. Ta-da! What the? Nothing happened. Uncaught syntax error, missing something after argument list. Preview file is not defined. It's a good thing Google Chrome has great debugging tools. Where is it? Show me.
The code you need to.
Your code is not. It's a UTF encoded code. When you paste it from Google,
you cannot paste it.
Sublime. Are you serious?
Yes.
What? I didn't know this. Where is my UTF encoded quote?
Line 81. 81.
Line 81.
And you think the code is not big.
Wow, it's a beautiful quote. I like that quote better. Say that.
What, line 81? Oh.
Let's try it again. One more time. Cat doggy. Open. Yeah! Let's see if it returns. Yeah! Ladies and gentlemen, it works. Round of applause. Now, you know, it's very difficult to do demos like this and sound so amazing because it looks so simple. It's like, wow, what an amazing thing just happened. But it's like, it's so easy. It's like, people are unimpressed. They're like, oh, yeah, return a cat. It returned mammal. But have you tried programming? Like, you know, have you tried making your own, like, identify this image? I give you a cat doggy like this. If I was your teacher, like, okay, this is your assignment, okay? You create an algorithm and a program. I give you this picture, it should return this. And then it should return accurately. Boy, that's like doctorate level. That's hard. But now, because of Cloud Vision, you have access to this kind of power. And this power made it look so simple. It's like having like a power drill. You know, before they do like the drill really... Let me show you something. It just reminded me of that. Was that jackhammer, how to use this guy. I don't know if you've seen this guy. Oh, come on. Load, please.
Jel ti se sviđa mašina? Jel znaš ti s tim raditi? Ajde vam
Oh, this one.
Bravo. Bravo.
Wait, say that.
Dobro, prigrijat će se, čuješ? I to si sve napravio za sat vremena, kažeš.
Da.
Bravo. Bravo. Svaka čast. Bravo.
I don't know who's gonna tell him, wants to tell him. But basically it's the same thing. Like you have the power, you can do it yourself and really do the algorithms and build your own image detection labeling algorithm. Or you can simplify things. If he just knew that he had to press a button, he would have like felt not so good because I just like, it's so boring, right? This one's like so much more exciting, right? So Vision API is exactly that, or the cloud machine learning APIs. Like they do the hard stuff for you, so you don't have to do it yourself. The side effect is makes it look boring, but it's okay. They can do all the hard stuff, so you can move on to the more exciting stuff, which is using technologies like this to build software that solves bigger problems, world problems. So your brain doesn't have to focus on building the algorithm anymore to detect images. You can move on to the software or the app that can, I don't know, like a drone app that takes pictures and then detects danger, alert, intruder, fire missiles. No, that's not solving problems. Maybe better, like, oh, that's a plant. Okay, plant. Put water. It can detect what plant? Oh, it needs less water, not too much water. Right? So you don't have to do the boring stuff. You can focus on the more exciting, real-world problem-solving stuff. Just like detecting what cat doggy is. So what is cat doggy? It's 99% cat. Well, it's a cat and a 99% sure. It's an animal. It's good. A mammal, it's a pet, and British short hair. And if there are any British people here, but what is a British short hair? And this is very interesting. Let's see. British short hair. Oh, British short hair is a type of cat. So not only did Google tell us it's a cat, it actually told us it's a type of cat called the British short hair. Did you know that the British short hair existed? It's cat. It's always cat. They're all cat, right? But we can go further and Google can tell us what kind of cat it is. So this is very useful. Let's try our other cat. This mean cat. Let's tell us mean cat. Sending. Cat 99. Pet, 99. Whiskers. Yeah, I can see whiskers. Mammal and animal. So that's pretty cool. It didn't say us what exactly the cat it is. Maybe it was afraid. It was a very mean cat. But let's look at here what Google actually returned. You see, the one we have on the left is already formatted. Like we made some HTML stuff so that we only get the pretty ones. But it responded to us this. So it gave us an object. It gave us an array of objects. The first array had a key, or the first object had a key of label annotations, and it had 5 label annotations. And the first one was cat. And it said the score is 99%, so 0.99. The second one was pet, and then so on. So we use that. So there you have it. We identified successfully a cat. And that's the end of our code lab. No, I'm just kidding. It's the end of the tutorial, but what I want you to do is I want to do a challenge. Like, you know, as developers, we shouldn't be spoon-fed. All just copy, paste, and then we don't know after the end. No, I just copy, paste it. Like, look at the source, look at the tutorial, copy, paste. No, I want to challenge you and do it yourself, but I will also do it in front of you right now. So what can we do? We can add several more features to this. So not only figure out a label for the cat, but we can also detect landmarks, detect faces. So first, let's detect landmarks, all right? Okay, the first thing we will do is go to cloud.google.com, and I'm going to search for images, vision. So I just want to make sure that I get the correct API parameters. So I go to view documentation. The documentation is really useful. And then JSON reference. It only has one method. And the method is annotate. And it has this ton of information what you can do in it. But I'm interested in knowing what we can get from Google Cloud Vision. So we have here, let me increase that. So we have face detection, landmark detection, logo detection, label detection, text detection, which is like OCR, optical character recognition, safe search detection to filter out explicit stuff. Or if you're that, you can just filter for explicit stuff. Image properties. We're gonna try first landmark detection. So in our code base, what we will do is we're gonna add to our features. Right now, it's a list. It's an array. Okay, so it only has one object. We're only asking for label detection. We'll say, okay, I want more than label detection. I also want landmark detection. So we just add another object saying, I want another one, type landmark detection. Save that. And then, let us see. Okay, we refresh our code. We get a file. We get another picture of the cat. Ta-da! Sending. Yay! Let's see what's our response. It has only one label annotation. Oh well, this is not really a landmark, is it? Right? So let's get a landmark. Let's see if we can search for a landmark. What do you want? Petronas Towers. What? Petronas Towers. So let's see. Let's give Google an easy one first. All right. Let's get this one. Let's view image, and let's get another angle of Petronas Towers. Let's see if it can detect it. Dun, dun, dun. The internet is loading. Because we are all loading at the same time. Alright, let's save this image. Put the pictures. Let's change it to PT. So we don't include the file name. But we don't really send the file name. We just send base64. That was a stupid move. Alright, so we have the Petronas Towers. We added it there. Let's choose a file. PT. Open. Wow. Sending. Dun 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 dun. Why am I doing JAWS? Alright. Object. Responses. We have two! Woo! Time to play some music. Where's my music? Guys, this is Surface Celebration. Alright? It was able to do, but of course you're not so excited, you're not dancing with me because we don't know yet if it's correct or not, right? So first we have label. Let's look at the label. It's a skyscraper. Correct. It's a tower block. I don't know what a tower block is. Residential area. Is that a residential area?
No.
No. It's 85% sure. Okay. It's a tower. Alright. It's a city. Right. It's in a city. Now let's go to the landmark annotations. Landmark annotations, we have one. It's the Petronas Twin Towers! Now we celebrate, ladies and gentlemen. Alright, so it gave us not only that, but it gave us the bounding. Keep quiet. Okay, it gave us the bounding parameters of where it is. So you know how this morning there were like, in the demo, it's like a bounding box of where the face is. So you can actually put a bounding box of where the Petronas Twin Towers are. These are the X and Y coordinates for this perimeter. And then location, it also gives you the latitude, longitude of the landmark. Yeah, you have a question? What? My face? You want to check out what Google thinks of my face? And location. And my location? We'll see. Okay, that's very good. All right. Okay, so we also take a picture of you. So that's me and you, okay? All right, so... Okay, so it works in the Petronas Twin Towers. So let's find another angle, okay? Let's find another angle of Petronas. You know what? Let's send it a picture of what I took last night. Where's my Google Photos? Hold on. Because, you know, Google already knows it's Petronas Twin Towers because we're getting it from images.google.com, right? So we'll get one here that I took a picture of.
Yeah, that one.
This one, huh? What do you think?
Yeah.
Download that, okay. So we got it there. We downloaded it. Alright, so let's see, Pokédex, choose file, downloads, this one. Yep, it's that one. Open. I have not tried this before. Okay, so remember, let's see. It's a skyscraper, it's at night. Wow, yeah, I know this, I do. It's a tower city and there's light. Alright, so what is the response? Taran, array 1. Oh, that's 2. Alright, landmark annotations, object. It's still the Petronas Twin Towers. That is super cool. That's even only one tower, right? Okay, I just love it. I had a lot of fun doing this because it's just really amazing. Now, obviously, I don't know, it's not perfect, but it's just great. Like, if you show this to a normal person outside Malaysia, I wouldn't know what this is. I have to see the Twin Towers so that I can be like, oh, there's the bridge, oh, there's the Petronas Twin Towers. But with this, you're only seeing half of it, and it can still tell it's in the Petronas Twin Towers. It still gives you the location, it still gives you the latitude, longitude. So that's really, really great. Okay, let's move on. So enough with landmark detection. What else do? We can do logo detection. So let's add logo detection. Logo detection. Let's add this logo detection. So I didn't include code to like display it. You know, that's trivial for you. You can do that on your own. You can format whatever way you want. But we're just seeing the source code coming in. I mean the raw code. I think it's better so that also everyone can appreciate, even if you're not JavaScript. We're doing this for you, brother. And you're not even listening. I said we are doing this for you. All right, so does this make sense? You can follow it? Code makes sense? All right, that's good then. Okay, so we do logo detection. All right, okay, so logo detection. Let's refresh it. So what will we choose file? I have some sample here. It was, let's see. Desktop, no. Pictures. So I have here like tech logos, right? Just like, before we do that, we do Google. You know, let's see. Let's throw Google its own logo and see what Google thinks of himself. Open. Sending. So it says it's in the label detection. It says it's text, it's art, it's a logo, it's a font, it's an area. I don't know why area. But let's see if it was able to successfully add logo detection. Oh yeah, ladies and gentlemen, we have logo annotations. All right, and then the bounding this is the bounding polygon, and then it says it's Google. No big deal. I mean, Google knows Google. All right, try making an algorithm for that. Let's add another one. Let's choose another one. This one I like this because it's like tech logos, right? Okay, so a lot of tech logos. Let's put it in. Open. Sending. It thinks it's a web page, a document, a computer program, and an area. I don't know why it says area. But anyways, what did it respond in the logo? It had 5 results for the logo. Obviously, it didn't see everything. It missed a few. But it saw Hitachi. Where is Hitachi? Hitachi. Right there, Hitachi. 1 point. SanDisk. 2 points. How do you say it? NVIDIA. NVIDIA. There. 3. BEA Systems. Wow, I didn't even know that company. Where is that? Where is BEA? BEA. Do you know that company? Did I miss it already? There, BEA, Think Liquid. Wow. And finally, PayPal. Where's PayPal? Right there. And I asked myself, why no Google? Because Google is saying, that's our own logo. I don't care anymore. All right, so it wasn't able to detect everything, but it was able to detect us 5 logos. Okay. What else? Let's see if it can detect logos embedded within images, like normal photos. Let's see, Starbucks mug. Let's see if it can detect this one. Oh no, this one is more natural, right? But it's a small image. It usually doesn't work well with small images. This changes to a large, size large. Which one will you use?
The top left one.
This one?
Yeah, that one.
It's so clean. Maybe this one. So that there's not no distraction around, right? This one is too clean. It's like a shopping cart. This one, more natural. All right? So, this one. Okay, let's save this one. You know what? Let's not save it. Let's screenshot it. I'm going to screenshot it. Okay, we have the screenshot. Let's close that. Refresh. Choose file. Where is that? In my desktop, it's a screenshot. Right there. Okay, that's it. Let's open it. Let's send it over and let's see. I have not done this before. We'll find out together if it works. It is a mug. It's drinkware. Have you heard of drinkware? Oh, can you please pass me a drinkware? Athlete. I don't know why athlete. Tableware and a coffee cup. Maybe athletes like to drink coffee. I don't know. So let's see. What is it here? Responses. We have a logo annotation. What is it? What could it be? Of course, these are labels, but the logo is Starbucks, ladies and gentlemen. A screenshot of an image of a mug that had a Starbucks logo on it, and it worked. So, that's pretty amazing, isn't it? Okay, so we now have logo detection, we have label detection, we have landmark detection. To your favorite, what do you want? Let's try face. I thought you were going to say safe search detection. Face detection. All right, so face detection, let's try it. We can't do safe search detection here. It will not be very good to do on a public thing. So just run it on your own. All right, so let's go to face detection. Let's add it here. Type face detection. Save that. And let's upload some faces. So refresh. As you can see, I am like rubbing my arms like an evil villain, right? Like, yeah, let's see. It's actually very cold. My hands are like frozen already. I can barely feel it. So let's put some faces in it. So okay, so you want my photos where I've been. Let's see if it can see a face. Let's see a face here.
That one, the half one.
Where? This one?
No, underneath.
Okay, say stop. Okay,
No, go back up.
I'll go back up. All right. Which one do you want?
That one in the ship or the plane, the blue seats one.
This one?
The one next to it on the left.
This one? All right,
Yeah.
let's try that. Okay. Let's take a screenshot of that. Let's see, because I'm not sure if it can do a resolution like this, but let's take it. All right. It is so cold. All right, that is it. Question is, will it think I'm a face or not? So it's a sports. It thinks it's a sports venue. Maybe it looks like a stadium, maybe not, but it's actually another GCP Next Extended in Cagayan de Oro City in the south of the Philippines last week. So we have an object responses, we have object face annotations. It detected 5 faces, ladies and gentlemen. 5. The first face is anger likelihood. So not only can it detect a face, it can actually tell you what the emotion of the face is. So anger likelihood, it's very unlikely, so not angry. Blurred likelihood, if the image was blurred, no, it is very unlikely. So the bounding poly is what you will use for the bounding box of the face. So we can 38 degrees X, Y 326, so maybe this. I don't actually know. But you can plot it out, and then these are the bounding polygon. Detection confidence, 99% sure it's a face. Headwear likelihood, very unlikely, so no headwear. This guy surely doesn't have a headwear. Joy likelihood, very unlikely. So what is it really? It wasn't able to show the emotion here, but it clearly knew that it was a face. So now I want to show you landmarks. What do you mean landmarks? This is a face. The landmarks of the face. Did you know that your face has landmarks? Like your nose tip, that's a landmark. Your left lip, that's a landmark. So what they use these landmarks to do like facial recognition. Like in TV, like in the movies, they take a picture of you like surveillance system and like match 100%. Yeah, it's in the movies like that, but in reality, that's what they use for facial recognition. So these are the landmarks. So let's open it. There's a lot of landmarks. Let's go over it. Alright. So the first landmark is the left eye. The left eye and the position is X, Y, and then Z. It sounds like a 3D component, doesn't it? Like the Z axis. So I haven't really looked into that, but if you're really interested, you can look it up. So left eye. Next landmark is right eye. So if you can put the red dots, you can put it on the X and Y, so you could have like the landmarks of the face. Left of left eyebrow. Right of left eyebrow. So you have like left and right of your right eyebrow. Right of your left eyebrow. But the problem, what happens if your like eyebrow is like connected, right? Like Google, like I have a hard problem putting it there. So yeah, left of right eyebrow. Right of right eyebrow. Midpoint between eyes. Right here. Nose tip. Upper lip. So this one. Lower lip. It's not only detecting the face, it's detecting the landmarks. Mouth left. Over here. Mouth right. Mouth center. Oh. Nose bottom right. It's like you're wondering, are you having a code lab or an anatomy lesson? Nose bottom left. Nose bottom center. Left eye top boundary. And left eye right corner. Here. Left eye bottom boundary. Okay. Left eye left corner.
There's a lot of parameters.
Left eye pupil. It can see where you're looking at. You know, it's like the face is looking, but Google can tell what you're looking at. The angle is different. No, because you can correlate the left corner, the left corner and the right corner, and then the pupil and the distance between the two can tell where it's looking at, right? Hold on. So interesting. Right eye top boundary. Oh, so we're doing the right eye now. That was just the left eye, by the way. So the right eye pupil. Left eyebrow, upper midpoint. Oh my goodness, it can know if you're like doing like that. Or like that. Left ear trajan. What is the world is a trajan? Trajan. Trajan. It's near the ear. It's the ear. Okay, left ear trajan. Right ear trajan. Forehead glabella. Whoa. We need a doctor in the house. Forehead glabella. Chin gnathion. I have no idea. Google it. Chin left gonion. Oh my gosh. Chin right gonion. I am happy we're done with the landmarks. And then you have the pan angle. So is the face looking straight or is it panned? Oh, the pan angle. The roll angle. Sorrow, likelihood, surprise. Tilt angle. Okay, I think I might have mixed it up. I don't know. The roll angle is maybe like roll and then tilt. I don't know. Underexposed likelihood. And by the way, that's just the first phase. Let's do the second phase. I'm just kidding. So there you have 5 phases detected on this picture. 1, 2, maybe even this, 3, 4. I hope it detected my face. 4, 5. I don't know. All right, 5 phases. So that's face detection. Now, what's interesting here? What we can do is we've already done this. Text detection, label detection, logo detection, landmark detection, face detection. Let's do text detection. Right? Let's add the final one, text detection. Oh, that was stressful. The face, so many landmarks. Type text detection. Save that. That? That's still the aircon blowing on me. What? Last week. Okay, so we added text detection. Let's add something with the text. Does this have text? It has text, right? It says Starbucks coffee. Now, I've never tried before on tilted and like waving text, so let's give it a try. Let's see. Open, done. Spray some background music for suspense. Smog, again, smog there. Let's turn that off to see and concentrate if it really detected the text. So yes, space annotations, label annotations, logo annotations, and text annotations. What is inside the text annotation? Remember, this is just a screenshot that we took of a photo we got from the internet, okay? It's not preloaded, nothing like that. The first text is back off. So it was able to detect back off. So the Google Cloud Vision API is still in beta. So it will only get better from here. Alright? So it wasn't able to detect the wave text, but it was able to detect the one that was like back off. And then it thinks like, this is no longer. But as more images are added to the system, it becomes better. It gets trained and will be able to tell these things. So back off, what's the other one? Back only. And then off. Actually, the first response is all the text that you can find in the image. The second and the following ones are the individual ones. And then it has a bounding polygon, so that you can put a box where you can determine where it is in the image. Okay? Let's upload another image. Let's look for street signs. Let's see if I have street signs in my personal photo. Street signs.
You can just search for it.
What? I don't want to search for it because if I search for it, it's like Google already knows it, right? So, let's see. This one. Welcome to Pamilacan Island. Oh, it's a video. This one. Welcome to Pamilacan Island Dolphin. Let's take a screenshot of that. Okay. So, stop that. Alright, so let's go here. Choose file. Sending. Ta-dun, ta-dun. By the way, this is in Bohol. It's a nearby island in Cebu. It's like 1 hour away by boat. This is where we watched the Captain Phillips video. So it's an advertising. It's a billboard. It's a banner. It's a signage. It's like saying the 4 things that are synonyms anyway. Alright, so that's great. So let's see here if it has text annotations. And it does. Alright. What does it think it says? A lot of text. Well, the first one will contain the whole thing, and then the subsequent ones will contain each word that it finds. So let's read it. ECQ. It thinks it's a Q. EC. Oh, welcome to. This is new line. So it's like enter, right? Welcome to new line. Do. New line. And whale watching tour. Oh. The luxury of simplicity. Got this one. New line. In nature and people. New line. Program partners. It saw that, guys. Program partners. JICA. And that's the image. That's the there. So first ECQ, which is actually echo. Welcome to do. So it didn't catch dolphin, just do. And echo. Pretty good, isn't it? It calls for a celebration. Round of applause, guys. Alright, let's upload another one. Somebody's recording me. I'm not complaining. Alright. Let's look for a sign. If we can find a street sign. Let's see. Well, that's a t-shirt. Let's try that one. Okay. Let's send it over. Okay, sending. And it's sent, and what does it think? It's a t-shirt, vehicle, auto racing, motorsport. Wow, that's a tricycle. It is not definitely auto racing. Imagine auto racing on a tricycle. What? Yeah, Makati City in the Philippines. So, it's election time right now. It actually says, ang ganda ng buhay sa Makati. It actually means, oh, life is so beautiful in Makati. And then the irony is the guy wearing it is like having to do a pedicab thing, like a tricycle, like you have to pedal. So I took a picture of that one. It's quite ironic. Text annotations. What did it see? Let's see. It says, fair enough. It says, ing. It looks like an ing, definitely, right? You can't tell it's an A, but it's an ing. Ing ganda. It thinks it's a V as buhay sa Makati. www.makati.v.ph. That's pretty good, right? Round of applause, guys. Do you have a question?
Does text annotation work only with English, or it can detect like Russian, Chinese?
Russian. Russian, I do not know. Chinese, I haven't tried. So that would be your assignment, okay? You throw in some Russian stuff and some Chinese stuff, right? And also maybe even some Malaysian. What's your language here?
Malay.
Malay, okay. Throw in some Malay, Shan language, and then see how that works. And then you would know for sure. But ang ganda ng buhay sa Makati is not English. It is Tagalog, Filipino. So,
letters, right?
oh, you mean like the characters? Yeah, so try that out. I don't know. But yeah, just try it out. Remember, it's still in beta. Yeah, so there's a Google Translate API actually. It also runs on, it's part of the cloud machine learning platform. So yeah, it's a different API. So I don't know. I don't really know how it's internally. Maybe they use the Cloud Vision API to then feed it and use OCR to get the text out, and then send a translation API, send it back, and then I don't know how they actually do it, but definitely you can build it yourself using these two tools. So you can use the OCR, component data text detection, to extract the text. You can throw it to the translation API. The translation API also has an auto-detect language feature. So you don't even have to say, okay, this is from whatever language. So auto-detect what language it is, and then you can specify a You can specify a destination language, and then you have that same exact feature. And what took years probably of Google to invent that? I don't know if it took years. You will just then do in like overnight hackathon and you feel so cool, right? So that's the power that we have already because of these technologies that are made public, are made available to us even as students or basically anybody. So we now did text, we did landmark, label, landmark, logo, face, text. What else did we not do? Face, landmark, logo, label, text. We're not gonna do safe search, but we have the code. I have the code base. I also deployed it in Firebase via vision-demo.firebaseapp.com. So what's nice about this is that I can open it on my mobile, but I don't have Wi-Fi on my mobile. How do I connect to the Wi-Fi on the mobile? You can connect on it, vision-demo.firebaseapp.com, and then you can take photos of your person beside you and see if it can detect the face. So the code base for this is exactly the same. You notice it? It still does the whole label detection, face detection, logo detection, landmark detection. It doesn't do the text. And then I added a few things here so it will display the number of faces. So the faces count of the number of faces it can detect. So open that. Let me try to connect to the Wi-Fi. Well, also you connect to the Wi-Fi. Wi-Fi wireless at APU. 847. It's the same thing, right? TP. Is it capital?
Yeah, capital.
Oh, I've been doing this wrong. It's obviously capital. Why did I think not capital? It's very hard to type with frozen fingers. I just realized that. 033. It's like your fingers don't respond to your orders. It's like there's lag time. Done. Login.
Wow.
Okay.
I took a picture of my breakfast
yesterday.
yesterday.
Done with this one. Let's see. Vision-demo. Firebaseapp.com. Alright, I am in! I don't know if you can see it, but let's take a picture of you guys. Take photo. My favorite guy over here. Smile for the camera. Use photo. Alright, so it's there. It's sending. It says youth. Thinks you're young, man. Good. Audience, community. And faces, 5 faces. Round of applause, guys, for our Pokédex. Let me count how many people there's. 1, 2, 3, 4, 5. It wasn't able to detect the faraway people, but not bad, not bad. 5 faces. One more. Let's take another photo. Let's take a photo of what should we take a photo of? This one, the Kaluwar one.
Oh, it detected half a face. The person is facing this side, and they also detected half a face.
It looks weird because the image is like
It's a picture of my friend,
light
my
distorts it.
colleague.
But let's see what it thinks.
He has retired already, so.
Display device, room, signage, clock. Serves a round of applause. Let's see what else. What?
The carpet.
The carpet, the garbage bin. I knew it. I knew it was gonna happen.
Zoom in.
I'll just take a picture from afar. It's like somebody who just comes in right now, like wondering why are they taking a picture of the garbage bin? So there's our garbage bin. What does Google think? Google Cloud Vision. Pattern, crochet, bag, lip. Well, yeah, it noticed the carpet and the wall pattern.
Wow.
Sound detection? What kind of sound it is? Like the garbage bin? No, not yet. That's actually maybe a good idea for you to build on top of the cloud machine learning platform. Like the sound of stuff, and it can tell you what it is. Right now, what there is actually in limited preview is the speech API. You give it human voice, which is like me talking right now, and then you can output text or speech API. It's speech to text, and it can handle two types of input. First is just an audio file one time, or you can also handle streaming. So you can do like live streaming something, and then you can automatically like add subtitles or something. Yeah, so for example, if I'm talking and then you can have subtitles there of me talking, and then you can run that through the translation API, and then you can provide like other language subtitles. Now, obviously, I might say some funny stuff and sound funny on the other languages, but yeah.
Can we define our own set of objects? Because we are doing some research on medical imaging, so we want to detect cancers.
Right. So what you have is, okay, so this is a pre-trained model. It's a classifier model for pre-trained for images, generic images. Now, that works well in like, generic applications like what is this, what is that. But if you want like fine-grained custom detection, machine learning detection for something like that, like medical images to detect patterns in cancer or something like that, that's really exciting actually. I think you would need to build that on top of like TensorFlow. So it's like machine learning really, because you have to customize your model and you have to run it. And then I think the purpose of the Cloud ML platform is that you can run TensorFlow on top of the cloud so that the training is done faster. So what you will need to do ahead of time, while it's not yet being released, although TensorFlow is already available, try it out, is you would have to have people like go ahead and say, this photo was taken of a person who has cancer. This photo, this image is a person of somebody who doesn't have cancer. And you have as many of those images that you can use as training data. So there is some technical aspect involved in creating a model and customizing your model in TensorFlow, for example. But then once you input that and it works, it can then create your trained model. So then you can give it a new image that's not included before that nobody has classified. And then it can give its own classification and say 89% likely to have cancer. And if you have a lot of images that come in, you can then have somebody like flag that if it has a high threshold, or it can be sort of like informational as well, data to the doctor or to the medical professional. Does that answer your question?
Yeah, thank you so much.
Yeah. So Vision API is really more of like as a service, prepackaged for the masses. If you want like in ready to use, if you want something more custom, you can also do that. Use TensorFlow. So it's really custom. It also requires some level of technical expertise as well. But definitely you can use it. And then when Cloud ML is released, you can then use Cloud ML, Cloud Machine Learning, to put your models from TensorFlow and run them on the cloud. Other questions? It's not working with Russian. What kind of Russian? Russian. Okay, so it doesn't work with Russian on his experiment. So yeah, So, too bad. Alright, but it will definitely get better. Yeah, so Google has access to so many images all around the world. Definitely probably maybe more English than Russian, but eventually the Russian could be covered eventually. Or if not, you can build your own model and you could use CloudML to detect that. Let's take one more photo for as requested. I will take my own photo and let's see if Google detects me as a face. And where I am? Well, I don't think it can detect, or maybe where I am, no? But this is not, it detects landmarks, like where you are is a landmark. Like, it doesn't detect like, oh, APU. APU is not a very landmark, but it will detect like Eiffel Tower, the Golden Gate Bridge, the Petronas Towers, for example. All right. Sending. Chess. What the? Chess. We look like a chessboard. We're a toy. Games. Google thinks I'm a plaything. Board game. Faces. 0? Oh, come on. Let's do that again. I don't accept. Retake. It's blurry. Blurry. Okay, let's try this again. That one. Okay. Google better be right this time around. It's a pet! A Pomeranian. What in the world is a Pomeranian?
It's a type of puppy.
It's a kind of puppy.
Dog.
A dog breed group. Faces 0. Somebody is making fun of me. I don't accept this. I need a better background. Maybe you guys are screwing it up. Maybe I'm smiling too much. I look too cute. Person! 96%! That deserves a round of applause, guys. And music as well. A woman, 88%. What the heck? You know, Google Cloud Vision API will definitely have to get better from now on. So yeah, that concludes our Google Cloud Vision API code lab for today. Go ahead and use the API key for a few days. I'll be disabling it after a days. And yeah, thank you very much, ladies and gentlemen. Have a good afternoon.
Hello, Mr. Green. Hello.
I don't think I can hear you.
Hello. Can you hear me? Hello.
I'm just going to get started. Hi everybody. I guess you can all see me. I'm Ian Lewis. I'm just a developer advocate at Google.
Okay, please go on, yeah.
And today I want to talk a little bit about Kubernetes and give some updates and an overview about Kubernetes and containers. So let me just share my screen here. Can you all see this?
Okay, Mr. Lewis. You cannot hear me. Yes, oh yeah.
And all right, great.
So today I'm going to be talking about Kubernetes and give an overview of Kubernetes and an update, as well as talk a little bit about, give a little bit of an overview of Container Engine and what that is. But I won't get too much into that. I'll be mostly talking about Kubernetes itself. So just to give a introduction to me, I'm Ian Lewis. I'm a developer advocate at Google, and I work on the Google Cloud Platform. So I work with folks like Morita-san, who gave the presentation earlier today. And I work in and live in Tokyo, Japan. I've been in Tokyo for about 10 years. I've been working in APAC and doing lots of talks and things like that in APAC for a long time. So I'm really happy to be talking to you guys today. And I also do like Twitter and stuff like that. So if you guys are really want to hang out and give me feedback on the presentation or things like that, then you can get me at Ian M. Lewis on Twitter. So diving right in, so I want to give like a little bit of a context overview of like containers and so basically for the last 15 years, Google's been building like the biggest, the world's most fastest infrastructure, and we did this mostly for our services and to make things like Gmail and search work really, really well for our users. And not just like the data centers themselves, but Google's backbone network. So all of the networks that connect the data centers together, those are all built by Google and owned by Google. So we have our own network between the data centers that's very, very fast, and it's only used for Google traffic. And of course, so having built that infrastructure, that's enabled us to build all kinds of really great products, things like search and Gmail and Maps and Chrome and YouTube and things like that. So like things like like Gmail has 400 million users or something like that, and search has just billions of queries every day. So these are very, very large services that we have created on our network or on our infrastructure. And as part of the network, we've also we have edge locations in 33 countries, and we have over 70 of these edge locations. This is more than any cloud provider. So we work really hard to get people's traffic onto the network as fast as possible, and make it so that you can the end users can access the services as fast as possible. And then we're now starting to kind of focus on building a cloud platform that allows other people to make use of our infrastructure. So things like from big data to storage to computing to network and monitoring, but also things like development tools and value-added kind of services. So things like App Engine and Big Data and BigQuery, which where you don't manage the servers at all, but you just interact with an API that allows you to develop applications and utilize and access big data and things like that. And so not just in the services and in the hardware, we've also invested quite a lot in software technology. From things like our distributed file system, GFS, the Google file system, to things like MapReduce to handle big data, and to our huge database, distributed database Bigtable, and to Colossus, which really replaced GFS. These are for storing large amounts of files. We've made huge strides in software innovation, And we've contributed back to the community in form of white papers, which kind of talk about the architecture of all of these. And so things like MapReduce have spawned open source projects like Hadoop, and Bigtable has spawned things like HBase. And so a lot of these like architectural things have really helped drive innovation. And one of the most recent white papers that we've released is on our distributed container schedule called Borg. So this brings me to what I really want to talk about today, which is containers. So we've been, Google has been using container technology with Borg for over 10 years now. So long before things like, the industry has sort of kind of come around to containers, we've been using it for quite a long time. Every service at Google runs in containers. We start over 2 billion containers every week. So this is quite a lot of containers that we run. So these are essentially just processes, but we run them in containers. And so that gives you an idea of like how many of these containers we're actually running. And so we think that because we've been using containers for about 10 years, we have more experience with containers than just about anybody. We've been using it for a long time. We know what works and what doesn't. So Borg's architecture was written in a white paper that you can read online. So here's the URL to it if you're interested. But I'll kind of give a brief overview of what it does here. We have many clusters of Borg running in our data centers. And each cluster is about roughly 10,000 machines, or 10,000 servers, and is managed by a Borg master. So this is like a master server. And then each of those 10,000 machines are workers that actually run the containers. And each one runs what's called a Borglet on the master to get instructions on what to run. That's kind of a short overview of the architecture. But I'm going to kind of run through how we actually deploy an application to that system. So imagine you want to run an application like here in the data center. How would you actually run an application with so many machines, like all these machines in a data center or in a cluster? There are thousands of other applications that might be running here. And these could potentially step on each other's toes. They could interfere with each other by using too much RAM or CPU and causing the other processes to basically stop or not have enough resources to run. And there's also many servers. Like, how do you decide which server to actually run your application on, and which ones not to, and which ones how to make your applications be able to talk to each other on the network? So you can imagine that you tell the system that each application instance or each process that I need to run requires about a 10th of a CPU core and about 100 megabytes of memory. So you basically tell it how much CPU memory or resources you want to use, and then you can say, okay, I want to run 5 of these processes or 5 of these instances of my application. And you do that to help spread the load around for the application. So you do like maybe a load balancing or something like that. But this is essentially what we actually do. So from the developer's perspective, you give a Borg, you create a Borg config, and the user specifies this. And so what they do is they specify which cluster they want to run in, and then they just specify which application they want to actually run. So this is like basically like a container image. Things like ports that you want to use for the network so that your applications can talk to each other. And then you specify things like how much your RAM and disk you actually want to use for your app. So your application can use 100 megabytes of RAM, and maybe it uses so much disk and so much CPU. And then you can kind of tell it how many replicas or how many instances of it. So you can basically multiply the requirements here by 5 to get the total amount of resources that you're going to use. But this number of replicas can actually be quite large. You know, like maybe you want to deploy 10,000 instances. So you can do that as well. And like the server will, or Borg or the container scheduler will actually be able to manage that for you. So all you need to do is just specify a new number of replicas. And so when you do that, you tell the system to start these up, applications up, and then it'll actually start running each of the replicas. So I can say like, I want to run 10,000, and then it'll go actually find a place to run those and start running them. And so that can take a little bit of time, but you can see like, internally we have like these little graphs that'll show you as the application gets started up how many running instances are actually running and how much of the application is fully utilized. So the result of that is so what did we actually do when we deployed it? What we basically do is we just tell we save our application into an application store, and then we tell the master that we want to run our application. So we just give it our Borg configuration that we just wrote. And then the scheduler figures out where to schedule it, and it tells the Borglet to actually run the application. So it's, and then the Borglet will pull the application and start running it. So it's a pretty simple idea, and it just does this 10,000 times based on how many replicas you tell it to run. And so as a result of that, it schedules our little application. Say in this case we're running Hello World. It schedules it throughout the data center and runs 10,000 of our instances on different machines. But we don't actually tell it which machines to run on. It figures out which machines have extra resources that can run the application. And then it schedules it there. So we don't have to manage which machines are actually running the application. So this is really helpful because we don't have to like spend a lot of time worrying about where things are running and what things are, how to set up the network and things like that. Okay, so that's how we kind of do it at Google, but I kind of want to step back and talk, so like what are containers and why are they beneficial and things like that. So just to step back and talk about containers, like containers are basically a way of packaging up applications and all of the dependencies together into one file or one image, basically. And so that image can be copied onto the machine and then be used to run the application. So you don't actually have to install the dependencies on each server. So this is great because the container or the application doesn't depend on what's actually installed on each machine. It carries all of its dependencies with it, so you don't really care which machine you're actually running it on. So this is great because it means that we don't have to be dependent on where we're actually running the application. We can run it on premise or in our private servers or on our private cloud or public cloud environments. It doesn't really matter where we're actually running it. Okay, so why would we actually use containers? So probably many of you have actually used VMs before, so virtual machines, but how do they compare to containers, or what's beneficial about containers compared to VMs? So one of the things that's really great about containers is that they're fast. When you start up a VM, you have to start up like the whole operating system. So like it has to boot up and start like a regular server. But containers are just regular processes. They share the kernel with the running host. So you don't actually have to start up a full machine. You can start up a new container in a few milliseconds. So it starts up just as fast as any other process running on the machine. They're also portable, so I mentioned that all of the dependencies come inside of are packaged inside of the image. So they can be run on any server, and you don't really need to worry about installing all the dependencies and making sure that they're there on each server. And then last, they're efficient. So like when you start up a container, each of them have low overhead. They don't have to start up a full operating system like a VM does. And a VM, because it uses the operating system or starts up an operating system, the operating system has to use memory and CPU and resources. But for containers, you don't need to do that. You're just running on the host machine, essentially. And because of that, you can run many more processes or many more containers on one single host than you can on a regular VM. And you can also specify resource limits just like you would a VM, so you can pack more of them onto a single host server. So this can actually help you save a lot of money when you're deploying apps. So probably you have all heard of Docker before, at least. So Docker is the technology that people are probably most familiar with when talking about containers. It's the de facto standard for containers. And Docker is great, but it has some limitations. It's great for running containers on a single host machine, but when you want to deploy like kind of a web application or a more complex application, you have to do things like deal with multiple servers. But how do you deal with things like when your server fails or when a container fails? And how do you define what an actual container failure is? Maybe your container will be running, but it's not actually serving requests, or it's kind of broken, it's not working, it's kind of like a zombie container. How do you manage what an actual failure is, and how do you restart those applications? And how do you update your applications without having downtime? So if you want to update your application, you don't want to just push your new version and then restart all of your servers all at once. Because then your users will lose their connections or won't actually be able to continue to use their service while you're updating. So Docker can help with this a little bit using things like Docker Compose and Docker Swarm and stuff like that, but it's really just not good enough to handle all of these type of issues. So that's one of the reasons why we built Kubernetes. Kubernetes is a distributed container manager that is modeled after Borg. So internally, we've been using Borg for a long time, but it's kind of an old system and it's very kind of antiquated and it's not super easy to use. And it's also very integrated into how we run our data centers and things like that. And so it was just better for us to create a new open source that we could allow other people to use, and that would be much easier for other people to use and install. But the overall architecture is kind of based on Borg and on our experience running containers for the last 10 years. And we've also contributed the intellectual property for Kubernetes to the Cloud Native Computing Foundation. So this means that Google doesn't own Kubernetes. It's a community-owned project. It means that many open source developers and companies can be free to build applications and extensions on top of Kubernetes without being locked in by Google and what Google wants. But we don't own Kubernetes, but we are an active contributor to the ecosystem. So as part of that, we want to make Google Cloud Platform the best place to run containers. So we've created Container Engine, which is a fully managed Kubernetes service that you can run on Google Cloud Platform. But we want to make it easy by offering Kubernetes as an open source project for you to move elsewhere if you really want to. So we don't really want to keep you locked in. We want to be able to allow you to freely choose where you want to run. But we want to work really hard to make our service the best place to run Kubernetes. So that's like kind of an idea of like what Kubernetes is, but what is Kubernetes really like? I explained a little bit about how Borg works, but Kubernetes is very similar. Kubernetes has a master and a scheduler, and then it has each node, worker node, where the containers are run. So this is very similar to the way that Borg runs. And then when we actually run an application or we run a container, we run it in what's called a pod. A pod is a set of containers that run together on the same machine. And they have shared network and resources and things like volumes. So you can mount volumes together between the containers. And so they can also talk to each other on localhost using with the same network interface. So that means that they essentially look like they're running on the same machine, and so they can talk to each other and work well together. So this is something that we use a lot at Google. So you can think about things like web servers and then maybe a log service that your web server will send logs to the log service that's running next to it. And that log service will send the logs to your log aggregator or something like that. So you can think of it like Fluentd or Logstash or something like that. So these types of applications work well together locally. So now you've got all of these pods running on your cluster. How do you actually differentiate between them? Like you might have front-end and back-end applications running, so you would do that by putting labels on each of them. So any type of object, and so you can say these are my front-end pods and these are my back-end pods, and then you can use to select the appropriate pods. You also have something called deployments. So I mentioned that Borg you can tell it how many replicas to run or how many instances of an application to run. And you can do the same thing with Kubernetes. So deployments are a way of specifying that you have a particular application and then how many replicas you want to actually run of that. And deployments will actually handle keeping all of those services, those applications running. So say you have an application front end and you want to run 4 replicas, you can say that you want to run 4 replicas, and deployments will actually schedule all 4 of those and keep them running. If one of them crashes or dies, then it will restart that pod and make sure that there's always 4 running. So that's really good for like a self-healing system or a system that can be highly available. And then this also allows you to really easily scale up and down your application. So all you need to do is change your deployment to say, hey, I want to have a single replica. And when you do that, the deployments will automatically kill 3 of your pods so that you're down to 1 single pod. And so that will actually make it so that it's really easy to kind of scale up and down. All you have to do is change the number of replicas, and Kubernetes will kind of figure out it. Okay, so I'm going to try to start where I left off. And so deployments are kind of a way to build, to create replicas, and or a certain number of the same type of application. And so you can kind of scale those up and down by just changing the number of replicas for that particular deployment. And Kubernetes will kind of figure out how to to update to that particular number. So if you had, say, one replica originally, and then you changed it to 3, Kubernetes will actually find the difference between the number of replicas that currently exist and how many are that you actually want, and then figure out how many it needs to start up to make it to the number that you actually want. So if you tell it to create 3, it will say, okay, I have 1 currently, so I need to make 2 more because that's actually going to get me to 3 total. Another thing that's really cool about deployments is they allow you to do rolling updates. So you can basically do updates to your application without having any downtime. So because the deployment is a separate thing from the actual pods, you can just say, okay, I want to change the image that I'm going to use or the version of my application that I'm going to do. And the deployment will then do a full rolling update to the new version of your application. And so it does that by managing what's called replica sets. So this is actually the thing that holds all of your pods, a certain number of your pods. And so what the deployment will do is when you do an update to your application, is it will create a new replica set for you and for your new version of your application. So in this case, I went from version 1 to version 2. And then it will slowly start adding to the new replica set and removing instances from the old replica set. So here it'll start a new one over on our new replica set, and then remove one from the old replica set. And then it will continue to do this by adding one to the new one and removing one from the old one until you have moved all of your replica sets to the new version, and then it will delete the old replica set. So it basically moves from one version to the other one kind of slowly without having to have any downtime. You're not completely shutting off your application while you're doing the update. You actually can move from one version to another without downtime. So that's really great. But the applications are not really all that interesting unless you can actually talk to them, or if you can actually send requests to them. So that's why we have things called services. So services are things that allow you to say, okay, I want to create a backend service on a particular port, and that backend service will select on a certain number of pods. So we might have our backend service here selecting or picking our backend pods, and so when you actually connect to the service, so this service will actually create a DNS name and an IP address for our service that you can connect to on the port that you specify, in this case 9000. And so when you connect to that service, it will actually send the traffic to the back end. So what happens is, say you have a front-end service that wants to connect to your back-end service, you can connect on port 9000 to this back-end service name, and then that value or that traffic will get load balanced to all of your back-end services automatically. So you don't have to worry about creating load balancers or things like that for internal services. So this makes it really, really easy to make services that can kind of talk to each other. And you can also make services that are not just internal, but are available externally to end users by using load balancers or things like that. So you can imagine like web applications or other things like that can be exposed to end users via a service. So I'm going to do a little bit of a demo to kind of show you a little bit about how Kubernetes works and what it's like. And are we okay?
Yeah.
Okay. So for what I'm going to demo is kind of like a little like a little application. It's like a PHP application with a PHP front end and a Redis back end. So so this Redis is just a database that's going to hold some data. This is kind of a guest book service. So our PHP front end is actually going to, when you write to the database, it's going to write to the to Redis to store our guest book messages. And then I'm going to kind of demo like what that looks like from a Kubernetes point of view. So let me change my screen sharing a little bit. And share my whole screen here. So what I'm going to do here is, I have my guestbook application. And in here, these are kind of like a little bit of an old way of describing applications with Kubernetes using what's called a replication controller. But you can kind of get the idea of what the application is like, or how you would specify these sort of things. So instead of something like a Borg configuration, like I showed earlier, Kubernetes has configuration files specified in YAML format. So YAML is hopefully a little bit easier to read or and write than a Borg configuration. But here, what you basically do is you can say, like, here I have a replication controller. This is kind of like a deployment or a replica set. And you say, okay, I want 3 replicas. So in this case, I'm saying that I want to have 3 PHP front ends. And then you specify a template which says, okay, this is the containers that I want to run in each, or this is the type of container that I want to actually run. So here is the image that I'm going to use. This is a Docker image. And this is the name of the container that I want to use. And so, and it also, you can specify the port that you're going to run your service on. In this case, port 80, because it's just a regular web application. So here I'm going to create these 3 PHP front ends. And then I have the same sort of thing for the Redis backend service. And so here I have a replication controller, or replicas set for the backend. So in this case, I'm specifying 2 Redis slaves. So here is the Redis slaves. And then I'll have like a single Redis master, just 1 replica for the Redis master. So here, I should be able to create this using the kubecontrol control command. So the kubecontrol control command is the how you can use to is a command line utility that you can use to connect to Kubernetes and interact with the API to get information about like how many pods are running, or what sort of replication controllers or deployments you have, and things like that. And you can also use it to create new deployments or create new applications. So here I'm going to create my front-end controller. And now if I say get RC or replication controller, I should be able to see that my front-end replication controller is running. And if I say get pods, I can see that it's running 3, and it's actually trying to create the containers. And then you can also do things like get events, or which will tell you what the internally, what Kubernetes is doing. So this is kind of like the Kubernetes logs. So you can kind of see that it's it's successfully created the containers. But I don't think that they're actually running yet. It's actually pulling the container images right now. So I can say say watch here, and this will actually watch the log files as things are happening, and it'll update and kind of tail the logs here. So this shows that I've actually pulled the image, and that it's actually started my containers. So hopefully, if I go back to running get pods, I should see that all of my containers are running. So that's good. I've got that. And let's see, going back, let me just go ahead and create all of these things. So front end, this is my front end service that I can use to connect to my front end. So the front end service already exists because I created it earlier. In my Redis master, and my Redis slave, service as well as the controller. And I need to create the Redis master service as well. Okay, so now I've created all of the things that I needed to. So the front end controller, the front end service, the master controller, the master service, as well as the slave controller and the slave service. So I've created each of these. So front end service, then the controller for the 3 front ends, the slave service, and the controller for the 3 slaves, or for the 2 slaves, and then the master service and the controller for the master. So that's 6, 1, 2, 3, 4, 5, 6. And so now if I say get pods, I should see some pods starting up or starting. So I can see the 3 front ends that I've got here. I can see the Redis master. Let me actually make this a little bit smaller here. Oops. I can see the Redis master, the single Redis master, and I can see the 2 slaves here that are running. And if I say to control get service, it'll show me, this is a little bit off looking, but you can see the front end service, the Redis master service, and the Redis slave service. There's also a Kubernetes service here that you can use internally to talk to the Kubernetes API, but we can kind of ignore that for now. So we've got these 3 services created. So now that this is actually up and running, and this front end service has what's called a load balancer associated with it. So we can, if you run this on something like Container Engine, you can easily create load balancers. My front end service, if you look at it, it has this type load balancer, which makes this particular service into a load balancer that I can access from outside of the cluster. So if I go here and I go to the RPE address, I should see my guestbook application, and I can say hello, or and submit that. And it'll actually submit that to my application. If I reload this, I should still see it. Okay. All right. So that's great. So now my application is actually running in Kubernetes. Let's actually kind of visualize this and look at what it is. So like here I've got a little visualizer application run. So if I say look at localhost. So here's like a little visualizer application which can kind of help visualize like what's going on. So here I have my 3 front ends pods, and this kind of updates in real time, so you can kind of see what's going on. So I have my 3 front end pods and the front end service. So that's the front end replication controller and the front end pods, and then a front end service. And here's my master, my single master, and my 2 Redis slaves. And so I mentioned that Kubernetes will always keep the number of replicas running. So what happens if I actually just delete one of these? So let's go in here and find what the name of these pods are, and say we have this pod here. Let me just go delete pod. Let me just go, okay, deleted. we'll see that like it's actually really, really fast. Like it was actually way too fast to actually really demo it really well. But if you saw it, like it kind of turned yellow for a second there. And actually what happened is that Kubernetes immediately recognized that there was like not enough servers running, and so it started up a new one. So this is actually a different name. If you look at this, is like BYQ9. So the one that we killed was C3EU sorry. So this is the one that we killed, or we deleted, and then this is the one that actually got started up. So if we look at get pods again, we'll actually see that we have a completely new front end. Actually, this is completely different numbers. There are like IDs here. Not sure why that is, but yeah. So we'll notice that like here we have the old ones, but we have a completely new one here. So what the replication controller or the deployments would actually do is make sure that you always have the right number running. So you can also do things like you can okay, so we can you can actually always make sure that you have the exact right number running. So I'm almost done, but the last thing I want to do is, so my cluster here is running in Google Cloud, and I've got 3 instances here. This is a little bit small, so you might not be able to see it. Whoa, blew that up a little bit too big. So you can see that I have 3 instances of my cluster running. These are actual servers running in Google Cloud. But one of the things I can do here is really easily is just straight up delete one of these nodes and see what happens. So I'm sure some of the application is actually running on these nodes, or this node, but I'm just going to delete it and see what happens. So basically, like, Container Engine will always keep the right number of nodes running, so it'll restart this node, but in the meantime, Kubernetes will actually kind of be able to recognize that a node is kind of down and be able to kind of act accordingly. So in this case, it's probably going to wait for about 30 seconds or something like about 30 seconds, I think, until it actually determines that a node is down and then starts moving around the pods. So here it's realized that some of the pods are not there, and so it started up a new one. So if we do get pods again, you can see that one of our pods that was running before, it looks like it was this ISB14 was actually running on the node that we destroyed or we deleted, and so Kubernetes actually started up a new one to make sure that it's always running the right application or the right number. So that's good. Like if we go here and we run our guestbook app, we can still see that it's running, even though we've kind of deleted a node and it's still kind of still starting up a new one. So if I reload this and see what's going on. Okay, so it's actually started up and created a new node for me. So if I go, you can also do things like get nodes here, which will tell you the nodes that are currently recognized by Kubernetes. So here I have 3 nodes running, but Kubernetes still only sees 2 because one is still starting up. So if I do this again for a few minutes, like I should notice a new node starting up. But right now Kubernetes only sees 2 nodes, and it can actually only use 2 nodes. So what it did was it recognized that one of the nodes was deleted, and then it moved around the pods that were originally running on that node to one of the nodes where it could continue to run in order to make the application continue to keep running. So that's one way to actually have a much more highly available application. You can continue to use this, so like, I'm still working. is still kind of going according to plan. Obviously, you can't delete all of the nodes and still have your application working, but at least some of the nodes can still fail, and your application will still be able to handle that sort of those type of failures. So I hope that was helpful and that was informative. So and with that, I'd like to end my demo and maybe open it up to some questions or something like that, or if you have any. Do we actually have time for questions?
Yes, we do.
Okay, that'd be great.
All right, any questions, guys? Is there any question that you want to ask? All right.
Can you repeat the question?
How does Kubernetes compare to Docker Swarm? What's the advantage of Kubernetes?
Okay. So let me stop screen sharing. So one of the things that Kubernetes does a lot better than Docker Swarm is that kind of the stuff that I just talked about. Like if your node goes down or your container is crashes or stuff like that. Kubernetes will do a lot better job of being able to move those containers around to another machine so they can continue to run and continue to be highly available. So Docker Swarm can do that, but to some degree, but it's not the kind of as robust of a system as Kubernetes is. Also, Kubernetes has the concept of a health check and a readiness check. So these are actually called liveliness checks and readiness checks. So these are things that actually Kubernetes can connect to your app. Kind of if it's a web app, it can connect to it on HTTP and continually check to make sure it's still running or that it's available. So say you start up your new application, but your database isn't started up yet. Your database is still starting up. But your application needs to use your database. Kubernetes can actually check your app. Your app can provide a readiness check that says, okay, I can't connect to the database yet. I'm not ready. So you can tell Kubernetes that your application is not ready yet, and Kubernetes will actually not send traffic on the service to your application that particular instance until it's ready. So that makes it so that you don't have to worry about the order in which things come up in your cluster as well. So that's one of the really nice things about Kubernetes that's not really part of Docker Swarm. Obviously, things like services and service discovery is also built into Kubernetes, so it's very easy to get that working up and running as well. Does that answer your question?
Yeah. Thanks.
Yeah.
All right. Thank you, Mr. Lewis, for bringing us on an intro to Kubernetes. So thank you very much. And
all right.
All right. I'll give a clap to Mr. Lewis. Thank you very much for joining us.
Yeah. Thanks. Sorry I couldn't be there in person. It was really great talking to you guys.
Yeah, it's great having you here as well. Sorry for all the technical difficulties.
Yeah, no problem.
All right, I'm sure you guys are really hungry right now. So. One here is for the Docker code lab, right?
Yeah.
Okay, that's not many of you. All right, can I have a show of hands? How many of you have used Docker before?
I played around.
Awesome. So I'm not sure if all of you know, you guys are supposed to install this tool called Docker Toolbox. So anyone here haven't installed Docker Toolbox or having problems installing Docker Toolbox? Haven't or having problems? Haven't. Okay. Can you just go to Google and then search for Docker Toolbox and then download it for whatever OS? What OS are you using? Windows. Yeah. Just download for Toolbox for Windows and then you should be fine. So while we're waiting for our friend here to set up his computer, I'll just have a brief introduction of who I am. So my name is Kenny, Kenny Lim. I am a Docker support engineer for Asia Pacific region. So I sort of work directly for Docker. So yeah, if you have any questions about Docker products or how to use Docker in your workflow, just feel free to talk to me after our lab session. Since before this this meetup was decided, JT, the organizer, he sent out some surveys to attendees to see what are your experience level with Docker. So I found that most of the participants here they have 0 to minimal knowledge of Docker. So this would be a very beginner-friendly kind of lab for everyone on Docker. So you feel free to raise your hand and stop me anytime if you feel that I'm going too fast or I'm going too slow. Alright? So my friend there, we're just gonna start ahead. Are you okay with that? Yeah. So to start off, the material, because I'm not familiar with how this Google, what they call it? Yeah, developers. I don't know how it works, so I just do whatever. All my codes are on GitHub. So if you guys need to access the material, it's just go to Google and then search GitHub Docker birthday #3. Or you can just go github.com/docker/birthday-3. Can you see it? Do I need to zoom it in? No. Yeah. And here are all the materials you need for our lab today.
Oh, good.
Yeah. So
I didn't attend the other one.
yeah. So actually, this is the same material that because I'm an organizer for Docker user group in KL as well. So this is the same lab that I had last month, I guess. No, this month, early this month. Yeah. So head on to there. So what we're gonna do is there will be slides that you can use. I'm not gonna cover them because half of the slide will be explaining and introducing all the Docker products, and I'm not a salesperson, so I will skip that. Do you guys need explanation on what is Docker and how Docker works? Like, does anyone not know or know how Docker works? Like, what's the difference between, do you guys need explanation on that? Alright, cool. Alright, I guess I'll jump into the slides anyhow. Okay, just ignore the picture there, because this is team after Docker's 3rd birthday, which was last month. Alright, so I'm gonna skip this. I'm gonna start with introduction to Docker. So Docker started off actually not as a product. It was more of a internal tool that the company before Docker used. So let's see, all these can be skipped. So started in 2013. The company needed a tool for them to run VMs on Linux, and then they can distribute. They were actually a platform company, sort of a platform provider company, if you get what I mean. And then they decided that using VM is too heavy, so they came up with their own framework based on Linux container, which is LXC back then. So eventually they found out that, hey, this is a really great tool. Instead of just selling platform as a service, why not we sell this tool that uses containerization as a product? So here are some basic things that I can tell you about Docker first, since not all of you have used Docker before. So in Docker, there are some terminologies you have to remember. So something similar to VM, you have something we call Docker image. It's the same as your VM image. It's your base for everything. So you can use the same image and then you can spin up multiple instances just like how you can do in VM. And then you have container. Container is the runtime, an instance of your image, if you understand what I mean. Like it's a running instance of your image. So we call it container. And then you have Docker Engine. Docker Engine is the service that allows you to do all these things. It usually runs as a daemon. And then you have something called a registry. A registry is like, yeah, it's a registry. It's a repository. Imagine it's a repository. Not exactly. A place where you can store multiple repositories. So it's a place where you store all your images. Okay? And yeah, that's the basics. So why I'm gonna explain a bit why Docker is gaining a lot more traction nowadays. So back then, like 5 or 10 years ago, applications are usually deployed in one or a few servers only. Typically, the server is a very powerful server and then you keep all the binaries running on that machine. But nowadays, there's a paradigm shift where we move from monolithic applications to microservices. If you guys are developers, I'm sure you guys are using microservices nowadays. So services are now decoupled. They are not monolithic anymore. So we need to have this thing called you need high availability. You need it to be agile enough for you to update it every day, because not every day, like often enough, because your market needs are changing every day. And you need high availability, and then what else? And then you need to be able to do the same thing on multiple environments. You can, let's say, back then when developers are coding an application, they always have this problem when they would develop something that works well within the development environment, and then when they move to staging or they move to production and hey, it breaks. Usually maybe it's small things like oh, it's a different GCC version, maybe it's the wrong Java version, or maybe the environment variables are different. So these are all sort of like a dependency hell for developers and system admins. So Docker sort of serves as a solution for this. So using Docker, because Docker images are immutable, and every Docker image they are packaged with all the, when you write a Docker image, you have all the binaries and all the dependencies already stored inside that image. So it doesn't matter where you run it. You can run it on a Red Hat server, you can run it on Ubuntu. It will still run the same as long as you have Docker installed. So yeah, so I'm gonna skip this. And then, yeah, so containers, like I said, they package up your binaries and all your dependencies, and then it isolates software from each other. Well, what does it mean by isolating software? So you might have an application with multiple services, right? So maybe different services would require different dependencies. Back then, the only way to do it is, oh, okay, for this service, you run it on server A. For that service that is incompatible with the binaries on A, you have to run it on B with its own dependencies. But with images, you can run service A on image A and then service B on image B on the same server, if you get what I mean. Because the dependencies are all contained within their own images. And then container is a standard format, so you can move it anywhere. Like, it's really small. Like a Ubuntu's image, I think it's like what, 200 meg, I think. And if you use Alpine, it's even smaller. I think it's 60 meg or something. Yeah. So the fact that it's a very small and portable, so it makes it a good tool for you to use and develop across environments, and you can deploy it really quickly across platforms. Let's say you want to deploy on AWS, it's really fast because it's small. But if you're using VM, then it's slow and relatively slow. It will take maybe hours. And then, of course, then Docker as a company, we built a whole ecosystem of tools beyond the Docker engine itself to help developers' life much easier. So yeah, so Docker to the rescue for developers. So yeah, I'm gonna skip this. You guys can read this. So the thing about Docker that appeals the most is to the developers crowd, because now you can, like I mentioned just now, you can build your software once, and then you can run it everywhere, knowing that it will run the same regardless of where you run it. So it's a clean and safe, hygienic, portable runtime environment for your application. There's no more worries about missing dependencies, packages, or pain points during subsequent deployments. And then you can run each application on its own isolated. I think the word application should be service. So you can run each service in its own isolated container. And then you don't have to worry that it won't work with on different machines. And of course, with images, before you even build the image, you can do many testing within your application and then make sure that it works before you ship the image out. So yeah, so it's really no-brainer for developers to move from, say, using Vagrant or VM to start developing on Docker, because it's really, really fast. And you will find out soon enough when we start doing the demo. So yeah, so our friend back there, have you used VM? You have been using VM? So you want to know what's the difference between VM and Docker? Do you?
I think I know what it is now.
Okay, you know what is it. So any ops people here? SysOps? Okay, cool. Have you tried Docker before?
Yeah.
How do you manage your service nowadays? Like, how do you do configuration management? Do you use Puppet and Chef?
Bit of Ansible.
Cool
Docker
stuff.
is still sort of on the trial phases.
Okay, cool. I think the general idea is that developers love Docker, while sysadmins, they would detest Docker because it gives the control away to the developers. But nowadays, a lot of tech companies are embracing the ideology of DevOps, so we see a convergence of ops and devs. So yeah, so Docker is yeah.
How do you handle legacy type of applications to be placed into Docker?
Can you give me an example?
Let's say something that's not written to be stateless, and there's like dependencies on like a local database and things like that.
You can link your containers to talk to different containers. Let's say you have container A running an application, but it needs a DB, and then you have container B, or you don't even have to put your DB on container, because it's sort of not a good idea to put DB on container if you have high I/O. So maybe you have a dedicated DB, a bare metal DB. So you can specify within your application where does it need to connect to your DB, what's the endpoint, what's the password and credential. You set it up, then you will talk to it. So it's all up to developers to adapt and transport their application, package it in a way that it can be done within a container. And it's really not that hard, as I will show you guys later. So yeah. So next, so yeah, this is the difference between container and VM. There is one caveat here, in a sense that when you run Docker containers on one machine, multiple containers on a machine, you have to take note that they all are leveraging on the same host kernel. Meaning that whatever you have only one host and then you're running 10 containers, they are all sharing the kernel of your host. So if your application, let's say you have 10 containers with 10 services, maybe one of the service requires a newer version of the kernel, then it wouldn't work if your host has an older version of the kernel. So that is one of the limitations of using Docker, but soon there will be unit kernel, but you guys are not there yet, so let's just assume that that's how it is now. Yeah, and yep, so you avoid the bulky part of having a whole stack of the kernel and all the binaries. So that's why Docker images are really lightweight, because you only have whatever additional binaries and your application code inside the images. The rest, they all leverage on your underlying host kernel. So since I've been mentioning kernel, just take note that right now Docker only works with Linux. For Mac, it's still in beta, you can try out. Because Mac is essentially Unix based, so they still share a major DNA, most of the DNA of Linux. Whereas for Windows, it's a totally different story. You have your DLL, you have your all the Windows stuff. So to run Docker on Windows, you still need a VM or a instance of Linux running on it. It can be running on Hyper-V or VMware or whatever virtualization technology you want to use. But for now, you have to use Linux. In the not so distant future, there will be support for Windows servers. I think Malaysia big enterprise, still a lot of them are using Windows, so there is this opportunity for Docker to do this, and they have been collaborating with Microsoft. So soon you will see Docker engine for Windows. But the biggest problem still lies that a lot of the images out there that people have written or organizations have provided, they are all for Linux. They are not for Windows. So Windows is exe, on Linux it's just your direct binary, you can just run it. So it's totally different. So I'm not sure how they would handle it in the future, because you will definitely not be able to run Linux-based application on Windows servers, unless you use VM. So yeah, so 3 years down the road, so now Docker is a container as a service. So you guys installed Toolbox, right? So Toolbox, it's actually, it has multiple tools. It has the Docker engine itself, which is running in a VM, so it installs VirtualBox on your machine, and then it installs a Moby Linux, which is a flavor that Docker created, and then it has Docker engine installed on it, and then you have Docker Compose, you have Docker, I think Docker machine is into, and then you have a fancy GUI, but no one uses GUI anyway. And then in the middle, you have all these tools. These are all the products that Docker has been making since day one. They are, I will cover all the different products in a minute, but it's not really a necessity to learn all these other services or other tools in order to use Docker. Those are just to help more advanced users to automate and try to make their life easier. But for the purpose of our lab today, we'll cover something very fundamental. So container as a service, as I mentioned, you build and then you ship and then you run. That's the motto of Docker: build, ship, run. There are two separate solutions on top of all the open source products. Docker actually has a few other paid products. One is called Docker Data Center, where you can run your Docker, the whole solution, Docker solution, on-prem or on your private cloud. And then there's Docker Cloud, which is like a free service, but you can pay to get more, say, free repo, private repo allocations, or more automated build queues. I'll explain to you guys later. So yeah, and then it helps enables, yeah, this is all just corporate propaganda. Yeah. So, right, so we will skip right to Docker app training. Right. So Toolbox includes Kitematic, Docker CLI, Docker Machine, Docker Swarm, and Docker Compose. So Docker CLI is essentially your Docker engine. And then you have Docker Machine, which is to help you spin up instance of VMs. It's sort of like Vagrant. I'm sure most of you have used Vagrant before. It's sort of like Vagrant. And then Docker Swarm is for orchestration of containers. So maybe some of you have attended the morning session on Kubernetes. The main difference of Swarm and Kubernetes is that Swarm doesn't do node management. We don't do resource management. We only do container or image management, if you get what I mean. So we don't do orchestration for your hosts, how many hosts. You have to add them in manually. But they do orchestration for your services or your containers. Like you specify how many containers you want to run for service A or B. If something happened to it, it will know how to spin up, spin down required containers. And then Docker Compose is just for you to build a stack of application. We will come to that later too in today's lab. So this is the ultimate goal of our today's code lab. We will try to build an app where it's a basic web app with you have your Python-based web app, and then you have your Redis as a cache, and then you have a Java worker that pulls from the Redis queue, and then you will store it into a Postgres database. And then you have your result app, which is another JavaScript app that will pull the result from your database. It's really straightforward. So it's like one component is your voting part, and then the other component is your result part. So, but before we start doing on this lab, I will go through some basic tutorial on how to use Docker engine. So as you can see, the material is publicly accessible at GitHub. So it's github/docker/dockerbirthday3. Yeah, so we will proceed then. So, right, I'm gonna skip all this because we're gonna start with something more fundamental. So, right, pre-tutorial preparation, right, so we will start here. Tutorial. So if you go to sorry, if you are at this GitHub page, there is this tutorial.fd. So it's the markdown for the tutorial session. So we're gonna start with a very simple tutorial. Those who have used Docker before, you find this very fundamental, but I'm just gonna cover just to be fair to the rest of the whole. All right. So everyone installed. Have you installed your Docker? Cool. So after you install Docker Toolbox, maybe Mac or Windows, you should have this thing called the. It should be called Docker Quick Start Terminal, right? Sorry. It should look something like this. Mac people, you would have that as well. Do you?
Yeah.
Yeah, so just run it. You guys can look at the tutorial. So when you start the terminal, what essentially it does is it will check if your default Docker boot to Docker VM has been started. If it's not, it will start it, and then it will SSH into the VM. That's it. No, it doesn't SSH into the VM. But it will connect your Docker CLI on Windows or Mac. It will connect to the Docker engine inside the VM. To make things more clear, Docker engine has two components. One is the Docker client, one is the Docker server, or we call it Docker daemon. So the CLI can be on any platform, but the engine itself, the daemon itself, must be on Linux. So let's say you have come to this page and then you type Docker version. So you should see that the client is version and API is Go API 1.5.4, blah blah blah. But you can see that the client is built for the Windows architecture, whereas for the server it's built for Linux. So in other words, your CLI is running natively on your machine, but the daemon or the server itself is running on a VM in Linux. So if you do a Docker machine ls, you should see that there's a default default VM running, and it's called, it's not there. But anyhow, it's running on, it's running on something we call Moby Linux. To see. So if you can see your Docker version, when you type Docker version and then it comes out, that means that your Docker toolbox has been installed correctly. Anyone not seeing both client and server? I'll take it as a no. So now, if you look at the tutorial, the first command to run will be docker run hello world. So this, when you do docker run hello world, it actually do this. It will say hello. This is just to prove that your Docker engine works. So what exactly does docker run do, or docker? What is hello world? What is docker run? So the syntax of running docker command is very simple. You start with docker. And then the second, the second part of the command is you can pull your image, you can push your image, you can run your image, you can start your container or stop your containers, you can list whatever container is running. So in this case, we run, and then what do we run? You need to specify what image to run, and then you tell it it's hello world. In my case, I have already have that image on my machine, so it doesn't download. But for you guys, you should see something like download pulling image, and then it would show the message eventually. So once you've done this, and then you do Docker images, this will list all the image that is on your machine. Image as in sort of like PMISO. So you can see mine has a bit more, but you can see that it has hello world here, and hello world is just 967 byte. That's how big that application is. And it is not exactly an application, it's just a very low level image that just echoes that message that you've seen earlier. The main intention of Hello World is just to show your installation was okay. Yeah, as it explains here. I mean, down there also, it says that it has installed correctly. So now we can do a lot more things. You can do. So just now I mentioned that you can manually pull your images from the internet. When I say internet, it's actually from default Docker Hub. It's a repository service provided by Docker. So if you don't have that image, you will automatically download, and then you will, if you do run, you will just download and run. But you can manually try and download as well. As you can see here, if you do Docker pull, let's say on pull Ubuntu, you will just pull like that. But then again, you'll be wondering, how do I know what images are out there? So there are two ways you can go about doing this. You can either go to Docker Hub, which is hub.docker.com. I'll just demo here. If you go to hub.docker.com, and then unfortunately you will need to create an account before you can use the service. I have an account. So you can search whatever you want. Let's say I want to search for MySQL container image. So you can just type MySQL up there in the search bar, and then you can search, and then you can have all these images that you can use. And then there are certain images that are tagged official, means that they are actually created either by Docker or by the application company itself. In this case, MySQL. Oracle is the one that's maintaining this image. So another way that you can do, which is sort of more the method that I prefer, is you can do Docker search. You can do Docker search MySQL, and then it will basically do the same thing as this, but in the CLI, and then it will show you the list of images that has been found with the name MySQL. And then followed by that, you can just Docker pull MySQL. Right. Okay, so if you look into the tutorial material, there are some other images that you can pull. So you can pull Hello World, Alpine, and then segments, static site. And then there are a lot more other images as well. While I continue with the lab, with this demo, just pull it in the background while you're listening to me, because I don't think the internet here is really fast, so it might take a while. Right. So you don't have to type pull one message and then wait. You can just copy the whole thing and then just paste, and then the CLI would run the subsequent pulls once the first one or the one before it has completed. So yeah. So now we're gonna do this very simple thing. Right. Let's go back to the tutorial. Yeah, that is site. So we have done back to the tutorial MD. So once you have done Hello World, we will start playing with Alpine. Alpine is just another flavor of Linux distribution. It's gaining traction lately because it's really, really lightweight. It's really small because it's sort of like a minimal kind of distribution compared to Ubuntu, where you have all the tools bundled in. So Alpine is a great candidate to be used for Docker-based image. So since Alpine is really small, it's like it's like 1 meg. So I think everyone should have finished pulling it So while the pulling for other images are running at the background, you can either start another session of terminal.
Okay.
In case you want to run it again, you can just start another terminal and then continue with our lab. So I assume you guys are developers, so you guys have used Linux before, right? So I'm not gonna explain what all this is. So let's say I do a Docker run Alpine, ls-l. So what this does is just very simple. You run this Alpine as a container, and then you tell it what command to run. So ls-l is just listing the default directory when you log into that container, or in this case Alpine Linux. So you will just list it, and then it will terminate the container, meaning that the container session is not sustained. It will just start and then list the file inside the container and then exit. That's it. So sorry, anyone see something? Okay, cool. So as you can see, on my 10-year-old laptop, I just do something like this, and it would spin up the container. It would print that output, and then it would terminate within like 1 second. So it's you try doing that with a VM, and then see how long it takes to boot up, and then load into load all the daemons, and then log in, and then you list all your files. It's gonna take a while, but on containers it takes seconds. Of course, it's not a full-blown OS, but for application, that's all you need. So how do I know this is not running? So for those who are familiar with Mac or Linux, you know the command ps. You can do docker ps, and then you can see if there are any running containers. So in this case, you see there are no running containers, meaning that when I did run, it started, and once it has printed the output of ls, it exited. So how do I know that? You can do docker ps -a, which means option for all, and then it will show you all containers on your machine. In this case, let me put it here. Container Alpine, the image Alpine was created a minute ago, and then it exited. So -a shows you regardless if it's active container or if it's a stopped container. It will show you all the containers on your machine. So this is how you can look at your containers. And you can do a lot more things, like in this demo it says you can Docker run Alpine echo, and then whatever message you want it to echo. You can do uptime. So for the sysadmin back there, when you do uptime, you'll notice something very funny. The uptime is very long. It's not seconds. Why? The reason is that, remember when I said when you run your containers, you are all leveraging your base kernel, the host kernel. Since you're running on VM, what kernel does it refer to? The VM kernel, the VMware kernel, the VirtualBox kernel that you have here, which is Docker machine ls. So in our case, it's this one. So it will show the uptime of that machine. It's not of that container. And then you can do other things. You can do Docker run Alpine bin/bin/sh. So if you do that, it would actually, for a brief second, you are connected to the shell. But then since you didn't tell it what to do after it connects to the shell, it would exit. So there's another option when you're doing run that allows you to maintain an interactive TTY session with a container, assuming that it has the shell that you want to run. So in this case, sh, the basic shell is in Alpine. So if you do include the option -itd, IT is fine. If you do docker run -it, the I option is for interactive, to let it to be interactive with your, let's say you have whatever input you have, and then T is for to create a pseudo TTY session. So if you do this, you are in a separate shell, a separate prompt, command prompt. So in this case, you are actually inside the container. And then now I can do whatever I want. I can check who am I can check which working that I'll root, I can check ls-l, and you are inside the container. And if you do exit or control D to terminate the session, the container would be stopped. Understood? So this is just to showcase how you can connect to a running, connect to the shell terminal of a running container. Right. So here in the slides, it's actually explaining why when you do without the -it option, why it doesn't work. Yeah, and then this is just teaching you how to list all your containers. So yep, and then it would explain something like you can try RF in container. It won't impact your machine. But be careful whenever you're running RF, just make sure you are really in the container. And then yeah, so these are the technology. We already established this. I'm gonna skip. So far, any questions about Docker, images, containers? Anyone?
When you save the file in there, when you terminate the containers and you run it again, will the files disappear? Let's say I save my database files.
Okay, so our friend back there is asking that, let's say if you start a container and then you exit, so what happens to whatever file is inside? So there's two things that you can, there are a few ways you can handle that. So first thing is, remember when so I'll do Control D now, so you will just exit. So now if you do Docker PS, there's nothing there anymore. So means that the container has been stopped. The file is still intact. So what you can do is, you can either start the container again by doing, let's say I do Docker PS, PS-A. So the last one exited was this trusting bell. The name is trusting bell, but I just go by the container ID. I'll do this. C Docker start trusting bell, and then I can make it. In this case, the container, because we never specified what to do when you start the container, you will just exit. But if you're running a database container, they have this thing called the, what do you call that? The command. When you build an image, you can specify what it does when it starts. So if you have that, when you stop your container, when you start it back, you will run back that process again. If you get what I mean. So in this case, we are unable to do it again, but there's another way you can keep your containers alive. When you do a Docker run, -it, right, you do D. D means detach, it runs at the background. So if you do this, and then you do Docker PS again, you can see that it's actually, it actually ran. My Alpine trusting bell is up again when I do Docker start. So to continue what you said, so let's say now I want to go back into that container. I will Docker exec. Docker exec is just executing command. I can do this. I'm in it. So now you can just touch a file, let's say test, and then you can see that the file test is there. And then you can just exit, and then you can, let's say you do a Docker stop to this container, to the container earlier. So it stopped it. So now if I do Docker ps, it has stopped. It has to be named, sorry. So it stopped, and then you see that one has been stopped. But I can start it up back again, and then I do a ls. And then you do, so you list back again, it started again, and then you do exec. This time instead of bin shell, you do ls-la. You can see that test is still there. So it actually, all these things, they are stored in your machine. It depends where you install your Docker binary. So if you by default, the Docker files are all installed at /var/lib/docker. Inside, if you go in, there's /container, and then there will be some container ID name, and then all the files, whatever is in this container, is inside that directory. So as long as you don't go actively, let's say now it's running right, Docker ps, and then I do Docker stop, my trusting bell again. So now the file is still there, but it's not running. It's just not running. You can restart it anytime, but there are times where you want to fully remove it, and then I'll just go on with the command to do it. So you can do it with docker rm. Before I do that, let me do this again. Docker ps-a, and then I try to grab trusting bell. As you can see, there's one that I just manually stopped. But if you do a docker rm, which is you remove whatever container files that are remaining for that container, and then you do again, you docker ps-a, it's no longer there. So meaning that container has been deleted. It's no longer available. So this is for container. So as I mentioned, a container is an instance, a running instance of an image. So I've just demonstrated how you can remove your container. What about your image? How do I remove my image? Let's say that image, I no longer use it, it's using up 200 meg of my storage, and I don't like it. So there's another command, it's called RMI. So RMI obviously is just RM image. And then what you do is, before we do that, Docker images. So you can see I have 8 images. Let's say I want to remove hello world, or I don't like it anymore. So you do with Docker RMI, and then you just type hello world. So I can't remove. Why? Because it says that unable to remove reference because there is some container is referencing that image. So it's smart enough to tell you that you cannot do that because I ran this image earlier as a container. So what you have to do is just docker ps-a, and then you grab hello world to get the ID. It's called Snippy Bell. Now I do a docker rm Snippy Bell, and then by now I should be able to do a RMI on hello world, and it would untag it from my machine, and then it will delete that file. So typically I never encountered issues with this, or I've heard customer complaining about this, because usually images are really small and storage is really cheap now. But some production, I don't know, there are some people that, some customers where they like to keep doing housekeeping on images in their machine. So take note that you always have to remove the containers from your machine. There's another way you can do docker RMI and then -f, it will force remove the image, but that's not recommended because you will leave your container dangling there. Alright, so this is these are all the very basic commands on when you use Docker. So the next thing we do is we do something more fundamental, something more practical, something that you can see, because all we have been doing is just starting up empty, very basic containers. So now I'm gonna spin up a web container, and this web container is nothing fancy. It's just something that it includes HTTPD, and then it has some static HTML files in it, and then it will show when you run the container and then you go to your local host certain ports, you can see that, hey, you already started a web service with some files in it. So as I mentioned earlier, this is one of the images you have to pull. So it's actually written by someone from Docker. So it's sequence/static site. So you will notice the notation is a bit different this time, where it has a slash here. So in Docker Hub, or in the Docker world, it's sort of like GitHub. I'm sure you guys have used Git before. So this part is actually your repo name, and then this part is your image name. Sorry, this is not repo name, this is your namespace. And then this is your repo name. Just imagine this is your company or your project, your name, your namespace, and then this would be your project or your applications. So in this case, this user, he created this image called static site. So what we do is, we will do docker run sequence/static site. So it will take a while, because this one has a bit more components to deal with, but it should be relatively fast. So once you run it right, you will see it just hung there, it won't stop, because I didn't run it in detached mode, meaning that if I cancel now, then the service will be stopped. But if you do a docker run -d, then it will run in the background. You will continue to be able to use this. So let's go back to, I'll use my separate terminal here. So if I do a docker ps here, you can see that it's up already. Do you see that? Yeah. But it's up, but how do I see my web app, my website, the website that I just started? So you are unable to see it because we never expose the port on that container to our machine. We never map it, meaning that it's only running on port 80 and port 443. If you can see on your machine, if you do docker ps, it's running on the normal your HTTP port and your HTTPS port. But you didn't tell it this is on the container. You didn't tell it on your machine itself what port to be published, so you cannot access it. So what you have to do now is very simple. So you can copy the actually you don't even have to copy this. You can just do docker set yellow, yes. It doesn't have. Okay, never mind. So if you run the next command, now you should see that this command here is slightly different from what we've been doing, in the sense that you add more options. So --name it allows you to specify the name of your container. If you don't specify the name of the container, it will randomly generate a container name for your container. Usually the format would be a adjective _ some person's name. So, but let's say we do this. Oh, sorry. You don't copy the bottom line. Just copy the first line. The bottom line is the container ID that is running. So in my case, the container ID is 282. PS is running. So here, if you do this, it will specify which port. Do you see here? It's different now. It says this is 0.0.0 is just your local host. The port 32769, it will be different on yours. It's mapped to port 80, and then port 32768 is mapped to the HTTPS port. So what I have to do now is I just have to go to my browser, and then I do localhost, and then I do port 32769.
Sometimes you have to use the IP address.
Oh, right. Because I'm not on Linux. I'm on. This is on. Yeah, it's on the virtual machine. My bad. So if you do Docker machine, it's running on 192.168.9900. Yeah. This would work if you're on Linux. Yeah, there you go. So this is your web app that is running. So it's just that simple. You just have to do a Docker run, and then you can see it running on your own machine. Of course, if you are feeling adventurous, then you can SSH into the machine. Let's say I try this static site. Spin sh.ls. So this is my CD. Okay, I can cat my index.html. Yeah, you can. This is the file. So if you exec and then you run the shell, you can modify the file, and then you can refresh the service, and then you will reflect whatever is changed, just like that. Okay, so that's that. So just now when we did this, right? Let me exit first. When we ran the command, we ran with a -p, capital P. Capital P, it tells it to map whatever port that is required on the container to a random port. It's randomized, so your Docker would try to find whatever unused port within your non-privileged ports. It will just try to map it. But if you want to specify which port to map to your local host, as you can see in the tutorial, you can specify it with a lowercase p, and then the syntax is this. The front part will be your localhost port number, and then this is your container port. You're just telling it that, hey, I want to map the container's port 80 to my localhost port 8888. That's it. So it's really, really straightforward. And then if you do that, and then you do on your browser, and then you go to 9900.888, then you will get the same thing. I'm not going to do this because it's just a repetition of what we've done. You can try it if you want. And then next, they will teach you to how to Docker stop the image, the container, and then you can Docker remove the container files. There's another command that you can run in case when you do Docker stop and then the container doesn't respond. So it's common in Linux world where processors don't respond. So what you do is, instead of Docker stop, you use Docker kill. So yeah, it's less elegant, but if your container is not responding, you can use Docker kill to force kill it. And another thing, there's something very cool about the Docker command line is that when you do Docker PS, right, there's two ways to stop or to reference your container. One is by your container name. In just now my case it was static site, or my second container is adoring Shirley. That's one way you can refer to your containers. The other way is you refer to your container ID. And Docker is intelligent enough that, let's say I want to stop my Alpine image, but I'm too lazy to type the full line or the full name. As long as it has a unique ID, let's say I have two containers now. The first one is container ID is 282B something. The second one is E41. So one starts with 2, one starts with E. All I have to do is just do docker stop E. It will match any containers that starts with E, and then it will stop it. But in this case, there's only one. So if you do it like that, just wait for a moment. And then you do Docker PS again, it's gone. So it does intelligent matching for your behalf. So it's useful sometimes when you want to remove multiple containers or multiple images. Right. So next, you can use Docker images to distort your image. So yeah. So far, when you do Docker images, you can see that the first row is always your repository name. Sorry, my one is not wide enough. Let me change the font again, slightly smaller. 16, I think 16. Yeah. So if you look at this, you can see that there's the second row. Second column, which is called tag. So tag is something like, if you use Git, you know what tag is, right? Anyone don't know what tag is? Tag is sort of like your versioning. So you can have, let's say you download Ubuntu, but you don't want the latest, because by default you will pull the latest. Let's say you want version from 12.004. Then you can specify by doing docker pull Ubuntu 12.04. You can tell it to pull specific that image instead of pulling the latest one. But of course, you have to be sure that the tag that you want to pull is already there. Again, to do that, you can use Docker Hub. Let's say I want to pull Ubuntu. Okay, give me half an hour more. Yeah, because I started really late. Yeah. Sorry, So if you do Ubuntu and then you click in, you can see tags. Here are all the tags available for this image. There are a lot of tags. So there's no correct way to say which image or tag to use. It all boils down to developer preference. So whatever tags you like, you test it and then you make sure it works with the application, then you can use it. So yeah, so these are all the fundamentals of running this. So next, I'm gonna try something a bit more special, a bit more in-depth. So we have been using off-the-shelf existing images. So now we will do something more adventurous, where you will try to build your own image. So this is done using Docker build. So to build your own image, you must understand how to write Docker file. Docker file is this file where it has this special notation. Docs. Let me show you how you can write docs. So Docker has this documentation page where you can look how to write all these things. It will teach you. This is the basic of how do you write a Docker file. So a Docker file will always start with a base image from something, followed by whatever you want to, whatever customization you want to do to the image. So you always start with the base image. So in this exercise, we will all this has been written. Of course, if you want to write manually yourself, you can. But to save you the trouble, and since we are running out of time, you can do this. So let's say this color is so hard to see. Let's say I make a directory called git. Oh, it already exists. Okay, it already exists. So nothing is there. So I'm not sure if everyone has git installed. Those that doesn't, please install git. So the simplest way we can do this exercise is just by doing this. You go to the top of your, go to the top of your, and then you copy this, and then you just do simply just do git clone. I mean, all developers, you guys should know git, right? So you clone the whole repo into your machine, which is really small, I think. And you have all the files of this GitHub repo on your machine. So this tutorial this Docker file that we want, this Docker image that we want to build, all the files required are already inside Flask app. Yeah. It's inside this Flask app folder. If you go to the original, the root of the repo, it's actually here, Flask app. So inside this Flask app, you have Docker file, you have your Python app. You have your Python app, the Python application code itself. You have the requirement for this application. People who use pip, you guys should know. And then you have templates inside. All these are all just the basic files you need to get this application running. I won't go into detail what's being done by the application, the Python code itself. You are free to learn online yourself, because this is just for demo purpose. I'm just showing you how you can create your own image. So the most important thing you want to look at is you look at your Docker file. So here inside the Docker file, if you cat or less it or view it with whatever text viewer you want, the first line will always be from a base image. In this case, the base image is Alpine. Second line, ignore all the comments. The comment is just explaining what the line run does. Second line is run apk. Apk is just apt-get lah. So you run apk add, and then you tell it to add Python pip, and then you tell it to install pip. That's it. So inside, whenever you run this, you build this image, it will do for you. It will download Alpine, it will start Alpine, it will go into the Alpine image, the container, and then it will add, update pip, and then you install it, and then you will copy the requirement file from your current directory, and then you will run pip install that application, and then you will copy your, in this line you will copy your application file, you tell it this is your source, this is your destination on the container. So this is, people who use Python app, you should know you can specify your app this way, and then you can copy all the files that you require here into the container. And then lastly, you tell it to expose what port. And then last part, our friend back there just now asked what happens when you start or stop a container. So if you have this CMD specified in your Docker file when you build an image, you will tell your container whenever someone starts this new image as a new container, what default command it would run. If you don't specify anything, then it will just run shell and then terminate lah. In this case, it would run Python, and then of course you need to tell it run Python with what. So this is sort of just telling it, it's sort of like you start your container, it stops at shell, and then you tell it to run Python space your Python application file. That's it. So in this case, it will run Python, and what file, what application to run? Python.f, the one that we just copied. So if you have all this, again, I'm not going to explain what the application does. You guys are developers, you know how to write your own binary, your application codes. So it's really simple. It's just you put in your binary or whatever your code is, and then you tell it, you tell the container what service or what application to run your code on. In this case, it's a Python app. Then you tell it to run Python and then the code. So we have all this. What do we do next? You do docker build -t. Docker build is building image. -t is the option to tell it what name you want to give it. So if you don't put -t, okay, let's see if I don't put -t and then I just say docker build, what to build. You put dot, then you will build the Docker file. Meaning dot in Unix term means current directory. So it will try to find the file named Docker file, and then you will build it. So when you do it, it will automatically find the Docker file, and then you will run whatever command is in the Docker file. And then you would have your image. So how do you see your image? Of course, you do Docker images, and then you'll be able to see the image. But then you don't have a Docker image name for that image that you just created. How are you going to refer to it next time? It's very troublesome. So it's always nice to always give your new image a name with the -t option. It helps when you want to use the image. As you can see, there's no name here. Sorry. There's no name, there's none, and then image ID. You can use image ID to refer to it, but it's, who remembers image ID, man? Like, if you have 5 of them, then you don't remember which one is which already. So you can do Docker build -t followed by, let's say I put cannylim / plus f. And you notice this time, the second time I run, it's immediately done. It's intelligent enough to cache your images that it knows, hey, this Docker file I ran before. I'm not going to run it again. I'm just going to retag existing image to rename it only. So now if you do Docker images, and you have my name there. I mean the image that I tagged just now. And then of course you can also do other stuff, like you can retag. You can retag your image by using Docker tag. Let's say I want to tag Docker my current image to another name, to cannylim say test app. It doesn't do rename, but it does a copy. So you see, they actually have the same image ID, but they have different name. It's for you to manage your images. Okay? So this is how you create your own Docker images. I know I'm going very fast, but it's really, really simple. If you have any questions, feel free to talk to me later, or you can just email me. If you want to know more, I'll give you my name card. Just email me, or hip chat me, WhatsApp me, or Slack me. I'll be more than happy to help out. Okay, and we are almost done, but not yet. There's actually a big chunk of tutorial that you guys should be doing, but I'm not sure if we have enough time. I'm gonna try anyhow. So we have done the static side. I've explained how you do all the fundamentals about Docker command. And then we've built an image. So now is the interesting part. Not all applications can be run within one container. Like, you can't have just one service application, right? Some application they have multiple services. As I mentioned at the beginning of this demo, we have an application that we want to do where we have a voting app and then we have a result app, and then it uses Redis, Python, JavaScript, and then Postgres. So again, the go here, yeah, down here. Just now the application you built already, actually you can run it. If you run it, the web page will load random cat GIF files. Yeah, it's internet. We love cat pictures. So feel free to try it out. Whenever you build your image, it's just docker run whatever tag you gave it. In my case, it's candylim/flask app or test app, and then you just do you check what port is it bound to your machine, and then you can see it. I'm not gonna do it now. So it's a repetition of what we've done. So now we go into the main part of this code lab, which is the birthday training. It's called birthday training is because this lab was written for the birthday event, but we're going to do it anyway. So people who don't have Docker Hub account, I would advise you to create it, but if you are lazy to do it, you don't actually need it, because the Hub account is required for you to push your image. Like, you already created it, but you want to share with other people. You can't really like bring pen drive around and then copy the image to the pen drive and pass to your friend. That's, I mean, internet age is kind of dumb. So you push it to some remote repository. In this case, we push it to Docker Hub. Docker Hub is free as long as you use public repo. Everyone is given one single private repo to test. But if you need more private repo, then you have to buy the allocation. It's sort of like GitHub, but at least you get to try one. Okay? So, yeah, so to get the voting app running, again, I'm not going to go into how, because this is a Docker lab, this is not coding lab like application, how do you write an application. So I'm not going to explain what the code does. I'm just going to say, like I mentioned, there's a voting component and then there's a result viewing component. So again, we will do a git clone. You already done the git clone. So just now I've done the git clone. Where am I? I'm at the Flask app. So I will go into the example voting app. So if you see, I'm inside the clone repositories, which is Docker birthday tree, and then I'm inside example voting app. And then if you list here, you can see that there's a file called docker compose.yaml. So this is a file. Just now we have Docker file to build image. Now you have Docker compose. It's a separate file to build a stack of services to be an application. So Docker compose is, you just view it as a file that defines your application. It has the whole stack. Whatever, let's say you have 5 services, you define all 5 services within this stack file. So if we do a simple cat or you less whatever, you just view the file. Oh, it's too fast. So I use less. So the first line is version. Again, how do you write all this, right? If I explain one by one how to write all this, it would take just 1 hour just to do that. Always feel free to use our documentation page. This is on docs.docker.com, but it's really hard to navigate because there's no search bar. So what I do is I use Google Docs, then you put Docker, then you put we try to find compose file, right? Compose. So it will give you the first return. It's most likely what you want. This is called the compose file reference. It will teach you how to write your own compose file. I'm just going to go through very briefly what the compose file means, each line. Version is the version of your stack. So if there's only 2 types, one is version 1 and one's version 2. Version 2 is for, it has more functionalities than version 1. It supports something we call overlay networking. it's only compatible with Docker engine that is 1.10 and above. But since you guys never used before and then you guys just installed, you should get 1.10 or 1.11, which has support for version 2. Next, we go to services. Services, this line means that what kind of service you have for your whole stack. So this part you cannot rename it anything. It has to be services, and then inside your services, you can have multiple small services. The syntax or the format of this is sort of like key value pair. So this is your key. My service key inside, I have working app, I have result app, I have worker app, the worker. And then inside, nested inside voting app, I have the key build, and then the volume is dot voting app. I have the key volume, and then the value is the location. So all these are like key value pairs. You guys are developers, you should know about service discovery, at CD, all those, they use key value pair as well. This is not exactly service discovery, but this is the notation. You have your key and your value. So all this, it's pretty straightforward. Build, when you say this is your service, you can put whatever name you want. And then you say build, it means that it will build the image. So I will tell it to build the image, and then where to find the Docker file, you specify here, dot voting app / dot. So if you see here, because my command prompt very dark, very hard to see, I'm going to show you on here. It says it's inside voting app. So we click in voting app, there is a Docker file. So you're telling it that, hey, I want you to build this service image, but the file is at a different place. Where to find it? And then you tell it volume. When you tell volume, right, you are telling it, I want it to mount voting app on my current host to the container /app. Understand? So in this case, it's using dot, so it's relative. So make sure you are at your command prompt, you are at example -voting -app this directory when you run this file, because it's relative to when you specify, it's relative to your current directory. And then you can specify ports. You're telling it, hey, map my host port 5000 to the containers port 80. For the network, I want you to create 2 networks called frontier and backtier. And then this thing is actually connected to both. You don't have to worry about what kind of network it will create. It will create it for you. You just have to tell it which network it's on, so that you can specify they can talk to each other on the same network. That's it. It's intelligent enough to do it on its own. So what's next? Result app, also same. You specify where your Docker file is. You specify what volume to mount it to the container, what port to map, and then what network is it on. And then you have worker. For worker service, we don't build our own image. We just use something off the shelf. Of course, this is written by someone else as well. We will just use it, and then it runs on back here. So this worker would, like I mentioned at the start of the demo, it will pull from the Redis server and then push it to the Postgres. That's all it does. And then your fourth service will be Redis, and then again you can use off-the-shelf image. In this case, it's Redis image. Remember that whenever you want to use off-the-shelf images, be sure that the image exists by searching it, and then test it beforehand. And then you can specify container name. This can be anything lah. And then you can specify what port, and then what network it's on. And then the last service will be your DB. Your DB image is based on Postgres version 9.4. This is optional, and then you can tell it volume, what data. You can mount a data to the containers via the Postgres data. You can mount anywhere you want, but in this case, we want to mount it to the data directory of your container. And then what network again? And then volume is just saying that, hey, I want for my this stack of application, I want to create a volume called TV data. That's it. And then last, you define what network they have, 2 networks. Of course, you can specify more clearly what IP, what subnet you want it to be, what subnet you want it to be. You can specify the range of IP, but in this case, we just want it to run, so we just let it default, and then you automatically figure out what private networks to use. So you have all this. Let's go back to the left. So you have all this. I'm just gonna show you how you run this thing. So all you have to do is you be on the same directory as your Docker compose.yaml file. So I'm at example voting app. That's my Docker compose.yaml. All I have to do is just do Docker compose up -d. That's it. -d means detach again. So you're telling it my whole stack is based on that compose file. And then you press enter, and then it will run everything that you need. You see, you will create the network, and then you will start with the first service. So first service need to build the image, so you will build the image. Second service need to build the image again. So it does everything for you. This is especially useful for developers who want to test the whole stack. Some commands might take longer, but if you run it on AWS, it's really fast. I think it's the network here is slow. And subsequent services, you don't even have to build them anymore. You're using images that you already have. And then there you go. You already have it. So now, again, if you do Docker PS, when you do compose up, right, it runs your whole stack for you. So if you do Docker PS now, you can see all the applications, the whole stack is running multiple containers. Just now we specify how many services we have. We have 5. You have your voting Python app, you have your Redis, you have your worker app, and then you have your DB, and then you have your result JavaScript app. So these are all the 5 containers we have. And then just to see it, because just now remember when we look at the just now when we start this, when we created, we specify the stack, we say that the voting app runs on port 5000 and your result runs on 5001. So now very simple, all I have to do is I just go here and then I go to my port 5000. I have that app. This is a very simple voting app. Of course, in the tutorial you would have to go and edit this so that it's a few of the programming language that you want to vote on. But I didn't change it, by default it's 1 and 2. So if you vote 1, then it will be cached inside your Redis. You get what I mean? And then if you go to your 192.68 and you go to 5001 and you have your result. Wait a minute. Let me run. Docker Oh, why is it not running? Is yours running on your side? Does anyone have problems seeing 5001? No, right?
No.
Yeah. So mine, I don't know. Somehow I have to check the logs. So if for your case, if it runs properly, it will show you a result app where it will show how many % of people voted on this, how many percent voted on that, and this is just a sample of what you can do with Docker. The main point is not teaching you how to write a voting app, but the main point is to show you that you can very easily import binaries and then make it packageable within a Docker image. It's just that simple. So it's like your normal server, your whatever bare metal server or VM or Vagrant you have, but lighter and faster. So once I have this, all this right, I have, if I do a Docker images, I have all the new images that I've written. I want to share with my colleague. All I have to do is I just have to, in my case, I have to do Docker login. You must have an account on Hub. And then the next thing you can do is you can push your images to whatever you want to your account, and then you can have your friends, and then they can Docker pull, and then they can get the image on your machine. So it's really simple. So any questions like?
Other than Docker?
Sorry?
Just say you want to deploy others, just copy the image.
Yeah. What do you mean Docker?
I mean, other than pushing to the Docker Hub to be shared, the other alternative is just copy it out.
Yeah, but that's not really, that's really troublesome because you need a pen, right? Yeah. And then you need to do a Docker export so that you export the whole file into the whole image into a file. Because actually Docker images are layers of, I'm not going to go into the details, but it's actually layers of all the changes that you do. You have multiple layers. Let's say you're based on Ubuntu, the first layer is on Ubuntu, then subsequently you add more stuff, then it's more layer. Then you have to package the whole thing into a zip, and then you move it to your friend, and then your friend have to unzip it and then import it again. It's
possible.
I think it's possible, but fastest way is still you either push to Docker Hub or you run your own registry. Like you run your own version of Docker Hub on your own premise. You can do that. It's free. It's called Docker Registry. I'm not going to cover it this time, but anyone interested, you can just talk to me. I can teach you how to do it. There are documentations to show you how to do it as well. Yes.
What's the latest ways to like slim down your image or like remove unused images?
Okay, to slim down your image, I would always recommend you start with the most lightweight base image that you can find. In this case, we have been pushing people to use Alpine. It's just 1 meg, so it has minimal stuff. So instead of like you know, when you install Ubuntu, it comes with a lot of shit. Then you have to forgive my language. Then you have to remove it, make it stable, and make sure it's secure. In this case, you have minimal, and then you add on whatever you want in your Docker file. You build your own image. You start with Alpine, and then you say your developer need all this, then they add apt-get install all this, and then you create that as your own golden image. Next time you can base it on that instead of a pure Alpine. Yeah, and for your case, how to remove, you can do, there's a lot of things you can do. You can do Docker, like I mentioned, you can do Docker RM. RMI is to remove your image from your machine. And then if you are using registry, you want to delete from registry, there are certain APIs you have to use to delete images from your registry. Those are all on the documents. If you want to remove all your images, let's say I'm going to not remove my images, I want to stop all my container or even images. Let's say I want to stop all my containers at one go. How do you do that? There's something you can do. Just now we have been stopping our images one by one, right? You can actually do Docker PS, and then you have all your container ID, right? You can do Docker stop space followed by the next one. You can have multiple to stop it. Or you're feeling adventurous, you can pile it on and then you do something like this. Docker PS -q. -q will just give you your container ID. So when I do this, it will stop everything I have. So when I do this, it will stop all 5 containers here. Yeah. And then when you do Docker PS again, there's nothing left. See, it will list out what it does. So of course, I don't advise you to do this when you're doing testing. I mean, it's unlikely you want to stop all the containers. But let's say you want to do housekeeping, then this is one of the ways. You can also do Docker RM and then you do docker images -q also. There are a lot of things you can pass around it. It's just like Linux command, it's very, very straightforward. Any other questions? I know I skip a lot of things very fast when it comes to Dockerfile and Docker Compose, but it's really fundamental stuff. The coding stuff, it's not important for you to understand it. All you have to know is this is the way you can build your image, and you can build a stack file, and then you can start the whole stack of application just within a few lines of code. It's really simple. So if no one has any questions, again, all these things, they are available on GitHub. It won't be taken away. Feel free to play with it, pull it, clone it. If you have any suggestion, do a pull request. And if you have any questions, feel free, let me find text.
So for Docker itself, you can't run on bare metal in your OS, which is right now just Linux.
Yes. We support all the major distributions, Ubuntu, Red Hat, CentOS, SUSE, all the Solaris, all the basic ones.
So what happens is you have the base OS, the Docker engine. So that's why they pull the Ubuntu is a minimal Ubuntu.
Yes.
So it's another.
It uses your own kernel, you have to remember. It always uses your own kernel.
But by pull Alpine there.
It's Alpine, it's still using the same, you guys all share the same Linux kernel.
Okay, sharing kernel, but it's running in the Alpine environment.
Yes.
Oh,
yes.
That way.
Yes. So here is my email and number. Feel free to mail me or WhatsApp me if you have any questions. I might not reply as soon as possible, but I will try my best. And I actually run a separate meetup group called the Docker KL meetup group. You can search it up on meetup.com or on Facebook. It's called Docker-KL. If you are more interested about Docker stuff, feel free to attend. Yeah, that's all I have for today. I hope you learned something new today. Thank you for coming. All right.
Done.
Yeah, sorry.
So so you give my so you present all the stuff.
Yes, everything. This demo, they a lot of them. I think most of them has completed it.
Okay, most of them completed.
The code files are all on GitHub, so you can access it.
All right, we'll share your resources in our.
Yeah, I give you the link.
Later, I have a check. Alright guys, thank you for joining us. So our friends upstairs already they ended early, and we will post all the materials, including the code labs that you haven't attended, to our webpage in GCP Next KL 2016 export.com, as well as our Facebook page. We'll email you a copy as well. Okay. So and also we will email you our feedback form. So please fill in the feedback form. Okay.
Okay.
Alright, so let us take a group picture together so that we can.
Okay, so just let me set up here. Okay, so good morning to everybody. I'm Albert. I'm a Google developer expert from the Philippines. I also have a company called SYMPH, SYM.ph. We're a web development, mobile app development studio based in Cebu, Philippines. So we cater to clients like government, enterprise, also startups, and one-person operations as well. We provide technical development. Most of our applications are run in Google Cloud, and some also on other cloud providers and regular servers as well. So today I'm going to be talking about, I'm talking about two things. So this morning session will be just sharing about the experience in San Francisco GCP Next 2016. So, and then this afternoon we'll have a technical session on the Cloud Vision API, amongst other code labs. So this morning will just be more storytelling. Later this afternoon will be the technical sessions. So, all right, let's do this. So we'll be talking about Google Cloud Platform. So Noe has talked a lot about it already. But I just want to share my personal experience. So the first speaker in the event was Sundar Pichai. If you don't know him, he's the CEO of Google, the new CEO of Google. And it was really surprising. He's not in the list of speakers. So when we saw him go up on stage, we're like, whoa, the big guy is here. Like the leader of Google is here. And so that was really quite a surprise, to be honest. And he talked about how everything in the future, or almost everything in the future, will be run in the cloud. And I think I really agree, and it's really true. The trajectory going to the cloud has just really been accelerating and increasing almost exponentially recently, and it's growing fast. So if you haven't tried the cloud yet, you should definitely try dabbling in it. If you are already using the cloud, then yeah, continue to just push on and do more there. The next speaker was Diane Green, and to be honest, I didn't really know her. So when she went up on stage, I quickly Googled her, and turns out she was the CEO or the former CEO of VMware. So VMware is a popular virtual machine company provider, or they're also known as the VMware software. So she's a CEO there for 10 years. It's like 1998 to 2008. 1998, that's about the time that Google was founded. So she was already the CEO of VMware, running it for 10 years. So she definitely knows, and she brought virtual machines to the enterprise. And that really shaped, like the virtual private server, like we share server farms where you could have virtual machines, and you could have even like shared hosting or something. And that really defined the industry the past decade. So now Google has brought her in to just lead the cloud side and amongst other things in Google. So it's very interesting to see somebody who's a veteran in the field of providing, enabling the enterprise come into Google as well, and just lead that side. So she spoke about why customers choose us, and she mentioned this interesting number, 9.9 billion, and I was like, why didn't they make that 10 billion? Right? Like maybe it's like some psychology. Like 2 nines over there definitely look bigger than one and then a 0. So $9.9 billion is like, whoa, that's a lot of money. So that's basically the Alphabet capital expenditure investment in 2015. That's like 1 year alone. So when I'm in the Philippines, I usually convert it to pesos because it's like our exchange rate is like 45 to $1. So that's like a whooping 450 billion pesos. I don't know what the exchange rate here is in Malaysia, but that's really a lot of money. And so that's only capital expenditure. That's not operating expense, meaning this money didn't go to developers. This money went to servers. This went to building data centers. This money went into things that would empower and enable the next generation of operations in Google, which now they are opening to the public. So that's a serious amount of money. That means they're really serious about their Google Cloud Platform. In fact, just having Sundar Pichai speak first said a lot about that. Like it was the first conference as our friend from Naui, right? Over Naui said like it's rare to have like the top people at Google speak at conferences, and that's really rare. And to have them just speak at the conference said a lot about their seriousness about the Google Cloud. So I was really happy about that. And the next thing I'm going to show you is the data center video. So what are they spending their $9.9 billion on? Well, okay, I have to switch this. Over here. So it's a very short video about their newest data center. I just want to show you the size. It's quite amazing. In the Philippines, we have huge malls. Here as well you have. But this data center of Google, let me pause that. I get that audio plugged in. Those are trucks. Oh, it doesn't have audio, it's a silent film. So look at the size of that thing. And the size, it's not a mall, they don't have shops in there. Those contain servers. Everything inside those are servers. Cooling systems, servers, that's just one giant computer. So they show this under construction. You see a crane now, you see more construction workers, the servers. So you have, man, I can't even afford one of those. All right. So that's where the $9.9 billion went, and now they have made it available to us. The next guy who spoke was Eric Schmidt. So now I was really surprised. You know, you had Sundar Pichai, and then now you had Eric Schmidt talking. He was not in the list of speakers, so it was definitely a delight. And he talked a lot about his history, about his experience in development. He started as a hex, and I don't know if I get this right, but a hex assembly programmer. Now, some of you may know that, but I don't know what that is. And later on, he then said that the next new thing that was invented was C. And that was really something new to them, and that was really an amazing new programming language. C, and I was like, whoa, C. That's a long time ago. And so he definitely had a lot of experience, and he just talked about how in his life, or in his programming career, there was just a new, increasing level of abstraction. Now, who has ever tried programming in assembly today? Oh, there are a few. Do you still program in assembly? Definitely. No, most people don't program in assembly. I think a lot of people don't program in assembly anymore. I think most people don't even know what assembly programming is. I tried it in school, it wasn't fun. In fact, we actually use HLA, it's called high level assembly. It's not real assembly, it's a high level one. And so, most of us don't know it, but it doesn't matter. Because in programming, it has just increased into layer upon layer of abstraction, and now we have Python built on top of C. We have, I don't actually know if Python is built on top of C, but Python has C libraries. And now you have even layers of abstraction above that. And so we just benefit a lot from these layers of abstraction. And the latest layer of abstraction is the cloud. So before you would have your own server, you would set it up, and then you have like data centers, and then you have hosting providers, and now you have the cloud. And in fact, on top of the cloud, we now have machine learning. And it's evolved so fast, and I want to give an illustration. I went to the toilet multiple times going this door, which is the wrong. Next time you go outside that door. But I went to the toilet multiple times this morning, and I don't know about the girls if you know this, but we have the urinal, right? So, girls, have you seen a urinal for the guys? You've seen that, right? So, before, you used to flush that thing. Like you peed, and then there's a handle, and then you would flush it. I haven't seen many of those anymore. In fact, I think there's a generation today that doesn't even know how to flush a urinal anymore. Right? They would just come in and pee, and if they peed in a urinal that needed flushing, they wouldn't flush that thing because they would think it's automatic. It didn't used to be. In fact, I think it's a great user experience not to flush a toilet. I mean, you don't know, you don't want to touch that thing because you don't know who touched that before you, right? So it's just good to have that red light blinking. Sometimes you wonder if it's a camera. And so, because like maybe it's somebody looking at you and okay, just done, flush it. Like, you don't know. But it's some sort of infrared thing. I researched this. Infrared thing that then detects if there's a presence of an obstruction nearby, and then the obstruction leaves. Therefore, the person left, and then it releases the valve, and then it flushes. Great user experience. In fact, we're just getting used to these things. There's now a new invention. It's called the no-flush urinal. For others here, it's a common thing. Have you seen these toilets, these urinals? The one they don't have a flush anymore? they just somehow absorb your pee. And the girls are like, wondering, there's such a thing. Because the ladies don't have that yet. They're probably thinking it's very disgusting. But we do. If you get a chance, visit a men's urinal. And you will see it's some sort of, sometimes you will see it very clearly because it has a sign in front of you. And it says like, this toilet is a no flush urinal system. It saves you 150,000 liters of water every year. And as you're peeing, you're like, wow, how you feel so eco-friendly. It just makes you feel good about peeing and all these things. But we now have the next generation of people who not only know how to flush, but don't even know what flushing is. This is increasing layers of abstraction. Our children, we'll tell them, before we used to have this flushing system where you would press a smaller button if you peed, and you would press a bigger button if you did another thing. And you should be aware of that. And this was a life skill we were taught. Did you ever wonder before which one was for which? Like, no, the bigger one is for the bigger one, and the smaller one is for the pee. No. The smaller one is for the number 2. I actually thought it was the other way around, Like the smaller one was for your number 2, and the bigger one was for the pee, because in user experience, the bigger button is the one you press frequently, right? So most people pee frequently, so you press the bigger button. It's the more prevalent one. And if you did the rare thing, you would press the smaller one. That's how I thought about it. Obviously, I was wrong. My parents didn't teach me. They didn't have this before. So these are life skills that we are taught, and we know. And for some of you, you just learned that. But now we don't know about these things, or we don't even need to. The children of today don't need to learn that as a life skill. And that's great. They can free up their brain power for more higher level things. You don't need to worry about the toilet flushing anymore. You just have to worry about bigger world problems. Now this may seem trivial and unrelated, but in fact it is very, very relevant. Computing services and software development has evolved from DevOps, system ops, like you have to watch the logs and you have to set it up properly and all this networking. And it is now evolving to no ops. No ops meaning no operations. And the nerds in the room, and I mean I can relate to this as well, it's like, no, you don't know what you're talking about. Like you really have to configure your servers because you want to tweak every tiny detail. Like you want to make sure it's optimized. It's like the flushing thing. You have to know whether you press a small button or the big button. But the generations of today don't even care about flushing anymore. And sooner they won't even know that there is such a thing as flushing. Crazy times, isn't it? So in software development as well, we are reaching a time when people won't care anymore. Even software developers won't care anymore what system is running behind the scenes, what's happening, whether you're doing it via cluster, or as you can see, I don't even know what I'm talking about so much because, to be honest, I've used no operations for quite a while, and I don't even know what's happening behind the scenes. All I know is that I can serve 1 million users just like that at any given moment, and somehow Google does the rest. And the children of tomorrow, the people that we will be competing with, will be exactly that. In fact, machine learning has taken it a little bit forward, has taken another leap, wherein the people of tomorrow won't, or the people of today, because machine learning is already here, won't even have to learn how to program that much anymore. Before, you would take a doctorate study or a thesis or a paper in order for you to create an algorithm to determine whether a picture is safe for work or not, or whether if it was explicit content. And they had all these, and I looked at this, I researched this thing, right? And so they had these algorithms that could determine like the angle on the color. So they would look at like flesh-like color, and they would like draw patterns on it, and they would determine if it was limbs, like the angle, you know, if it was also open or closed, or I don't know, like limbs, and they would see if it's consistent. And somehow this was a doctorate study, and it could tell you if the picture was explicit or not. But now you just call one API, and now you have the result. And the doctorate person, the person studying doctorate submits this, looks at the kid nowadays and goes, "You're cheating. You're cheating. And in one way, it is kind of cheating. But that's exactly what's going to happen. And what's already happening already. Machine learning is teaching a new generation, or will enable a new generation to create applications that don't need programming. Ooh. So we better catch up. All right, we still have a job though. It's not that easy yet. So that's good. We still have a job. All right, so, but that's a generation. We definitely have to take part in it. The next guy who spoke was Urs Holt. I don't know how to pronounce that. So, I didn't know this guy either. But he sounded really smart. And when they said senior vice president, I knew he was definitely smart. So, he runs technical infrastructure. Basically, he is the guy in charge of all the data centers in Google. And he said 1,000 VMs in 5 minutes. And to be honest, I was like, whoa, this is supposed to feel amazing. Wow. I didn't know it takes that long. I didn't even know that 1,000 VMs in 5 minutes is an amazing feat. In the world of no operations, we don't look at this. Like, we don't really care how many VMs get spun up. The only question is, I'm spiking right now, we have a television ad, there are like thousands of users coming in every second, and now it's reached like 20,000, 40,000, 100,000 people. And are they getting errors or not? I don't care if I'm getting 1,000 VMs spun up. Spin 2,000 up if it needs to be, you know? And that's exactly what Google takes care of. But for the nerds in the room, or for the people who care, that's the statistic. Now you let me know if that's amazing or not. I do not know. But this one definitely feels amazing. You know, internet in the Philippines is not like this. It's like you change the G to K. So, and then if you're lucky, maybe an M. But then you change the big B to small b. Okay? So that one, that's pretty fast. Right? 2 gigabyte per second networking within their network. That's amazing. 77 locations of data centers. Now this is impressive. They have 77 points of presence around the world. And what's more impressive is that all those points of presence are connected by their own private fiber network. Meaning they have physical cables, wires, running from one data center to another data center all over the world. Thus, it's safe to say that Google has essentially tied up the world with fiber optic cables to connect all of those. Now that's pretty far. The trip from the Philippines to San Francisco took a total of 12 hours. That's only halfway around the world via plane. Somebody had to lay all those cables down. I'm glad we didn't have to do that. So you benefit with the 77 locations all over the world, meaning your signal doesn't have, you know, every time there's a request, it doesn't have to travel halfway around the world. But you don't really care about that. Basically, it's fast. And your users will definitely experience fast. Now this one impressed me. 0 to 1 million queries per second. 1 million queries per second, that's a great number. But what's greater is if you can go from 0 to 1 million in less than a second. It's like, you already have 1 million. From 0 to 1 million, like boom. And then, wow, you have a lot of users. You know, I don't know if we'll ever reach this sort of scenario where we'll get from 0 to 1 million queries per second in less than 5 years. That's usually the trajectory of like startups, right? Like, 3 years, 2 years. It's rare where you actually have a startup that goes from 0 to 1 million in less than 1 second. Like, I launched today, and I have 1 million users 1 second later. It's impractical, but just to let you know, if you ever need that, it's possible. But maybe it's not really about launching. Maybe you already have a system that runs about 1 million queries per second. And if you do, I'd like to talk to you. You know? And maybe you're you're migrating from one system to another. Like you wanna transfer the requests from one server to another, and the rate of those requests coming at 1 million queries per second, and you want to transfer it right away. Google can handle it. You can do like that, and it's done. Let's talk about important stuff. Let's talk about money. So, other cloud providers. I don't know if your advertisements are similar to the Philippines, but in the Philippines we have advertisements like, this is brand X compared to Google Cloud Platform. Google Cloud Platform is 59% cheaper than brand X. It is. And it's they actually break that down into, they even have a customer-friendly pricing. So you can avail of discounts for sustained use, for prolonged use, for preempted VMs. When you can get up to 59% savings. And I think it's a great time because, you know, Google is now coming into the cloud wars. And I think there are already a lot of cloud providers out there, right? And just Google joining in and just being part of that excites me. Because now you have more competitors. And usually when you have more competitors, the consumers win, right? Like, yeah, Google is cheaper. Now everybody will try to be cheaper and better, and that's great for us. And right now, Google is really cheap. So Google is winning. And so we should definitely try it out. Now, this is another interesting. This was in a breakout track. This was not in a session. But I just wanted to share about it to you. Have you watched this movie, The Walk? Have you seen it? Oh, okay. It's scary. It's like that. So this guy, this French tightrope walker, illegally tied a tightrope between the two towers, World Trade Center towers. So before 2011, no, I don't know when that was. 2011? No.
2001.
2001. Why did they call it 9/11? September 11, 2001. So before that, there used to be two towers of World Trade Center in New York. These are like one of the highest, or it was one of the highest in the world before. And this guy illegally put a wire between the towers and walked on it. This movie is about his story. Now the problem with filming this movie is they don't have the towers now. So they had to do visual effects. And they used 9.1 million total core hours in GCP. Rendering takes a lot of time. 2 years into video editing and then rendering. Now I run a company, we also have a marketing department, and so we have a guy who does editing, and so he rendered it and then he's shows it to me, and I'm like, oh, can we change the text, just this one? He goes like, and the rendering will take so much time. I was like, yeah, but it's just a small change. Spoken like a true project manager. All right, so it's just a small change. And rendering takes a lot of time. In fact, for large screen formats, it takes so much time that for this movie, for 10 minutes in the part where they did the whole scene, it took 9.1 million total core hours. Before, what they used to do, or what they still do sort of in Hollywood right now, is they have what they call render farms. They have arrays of, they have like a semi-data center, a semi-data center, and they just do rendering in there. Let me read some statistics from their blog. There's a blog post here. Why does it switch? Did I close my Chrome? Oh no, I think I closed it. Yep, I did. Okay, let me just... Oh, I know, I made it full screen. Okay, okay. So some of the statistics. Here. Let me make this clear to you. A single iteration of one frame, which is 1/24th of a second. So you have 24 frames per second, right? So that humans can be like, whoa, it's animated, it's smooth. Has 83 gigabytes of input dependencies. I was like, what? One frame? 83 gigabytes of, yeah, that's how crazy it is. It takes 7 hours. 1/24th of a second takes 7 hours to render on a 16-core instance. And I thought rendering was slow on my Mac. And so that's why they have render farms. So what they do now, instead, is they spin up thousands of instances on Google Cloud. They send it 1 frame each to render. And then they wait for 7 hours. But at least now, they have 1,000 frames coming in at the end of 7 hours. So the guy renders it at night, sleeps, goes back the following day, and when he wakes up,
render error.
Render error. beautiful day. Oh, I gotta run the render again. I'm day off. And so that's exactly what they do. Now I just want you to think about that. The next time you queue up in a movie and think that paying how much is the movie now here? 15, 16 MYR? Yeah, somewhere there. Yeah, just think about that next time. You know, I was like, this really made me consider like downloading movies. Like I was like, whoa, it's expensive, and I just like click download. So time to give back. 9.1 million core hours. They spend a lot of money. Amounts to a few $1 million just for the rendering alone. And that's the walk, only 10 minutes of rendering. Now imagine the Transformers, Avengers. They have so much more visual effects, right? Oh, no wonder those things are expensive. Now this was one of the things that Urs also talked about, was this is where we are previously and even now. This is basically DevOps. So you select an instance as a service. You know, most of you know this. You set up an OS. You can do containerization now. That one I'm not so sure. I don't know about. You have then set up storage and container orchestration, networking, monitoring, logging, testing, and then finally the user. And for this DevOps guys, this is sexy. This is like, ooh, yeah. Oh, he's waving to his friend. I thought you were waving to me. Sorry. It's okay. So this is like beautiful. Like you can see all the things and connect them. And this is so geeky stuff. And I love it. And this is the future. No ops. Just like a toilet, someday you will not even know what flushing is all about. It's a layer of abstraction that's coming upon us. And we need to evolve with it. And the cloud platform is a perfect place to do no ops. But at the same time, it's also scary. Some people are concerned about things like security. You know, I was asked one time in a conference before I gave a talk, and the person asked me, "Sir, how can I convince my client that to migrate to Google Cloud? Is it secure? Like, how will I ask about security?" And so I had to ask him, "Okay, let me ask you, how many years of security, web security, or just server security experience do you have?" And he's like, "I have about 5-6 years experience." I was like, "Wow, that's pretty good." Well, Google has about several hundreds of people years experience and around 500 security researchers dedicated for security at Google. Tell your client that. And tell him to make a choice whether to pick you or Google. So it's an easy choice, and it's definitely an easy choice. What are the things that they're doing? So two-factor authentication. They have data loss prevention. I just love that because have you experienced like my DB crash, corrupted? Oh, where's the backup? 500 security researchers. Oh, I was close. Elliptical curve cryptography. I don't even know what that means. Encryption by default. Wow. Physical security. Physical security means they have data centers and they're guarded. Like, for real. Not like, like you can get in. In fact, I was told that less than 1% of Google employees have ever been to a Google data center. They don't even trust their own employees. I was like, that's pretty neat. Thinking of Edward Snowden. The NSA definitely trusted him. Look what got him to. Google doesn't make the same mistake. So they have cloud security certifications. I only know PCI and ISO. The rest, that's a bonus. And there's this really handy data center tour. I don't know if you've seen this before, but let's do it now. So let me just do this, and let's play it. And I hope the Wi-Fi still works. Electronic music. So you can experience this using the Google Cardboard. You can do like a 360 tour. What happened?
Internet.
It's still moving.
The cable?
Is this like stereo? How do I do mono? Okay, I'll just do it. So let's go on a special tour. Okay, there's the guard. Wait, you saw that? You did. There's a guard right there. And now we're buffering. Okay. Alright, let's go in. So this is the lobby. If you can look around. Should I pause this? Are you doing something? The volume, yeah. No. Oh, HDMI. I should have to. Just give me a moment. Sorry. Sound. Output. Headphones or HDMI? Okay, let's try this one.
One of these systems goes down. We designed our systems from the ground
Alright, so while they're
up to
talking,
be able
let's
to
take a
handle any
peek around the
unexpected
Google Data
failures
Center.
that might occur.
So they
We
have
highly
this.
redundant power, networking, and serving domains. So that even if we do lose an
It's
entire
like a
cluster,
rock
we're
climbing
able
thing,
to
a wall
redirect
climbing
those
thing.
workloads and live
Like,
migrate
wow,
data
they're
in order
training
to
them to
minimize
like
any
and
impact.
scale the Google
In
Data
addition,
Center
we have a
walls.
team of SREs on call 24/7 that can tackle any problems that might arise.
This is like
Thanks,
a
Noah.
special
So now we learned more
door.
about the systems that
So
manage our
only
fleet
one
at
person
Google.
can go in
Let's
one
take
at a
a
time.
deeper look at the
Like
data
it
center
closes when you're like
infrastructure itself.
authenticating. It has like biometrics, and then you have a badge.
Welcome inside. Before we can continue further, we need to go through the biometric.
Okay, the biometric. But wait, it has to be. We'll add some cool experience here. Let me pull up my music.
Iris scan and circle lock. These only allow one person in at a time and require dual authentication to continue further. I'll see you on the other side.
Alright, enough. Let's pause that one. Okay. Ooh. It definitely had the feels, didn't it?
Welcome to the data center floor.
It's
As you can
noisy.
tell, we have a lot of servers.
But can you see the guard?
Just a single cluster.
You guys guarding this guy. It was like, and I'm interested, maybe you like suddenly put the thumb drive in the server, extract information.
To utilize our fleet, we use tools
Look around.
such as Borg, Colossus, and
Wow, look at
Standard.
all these things we can't
You may
afford.
be familiar with similar tools such as Kubernetes,
That's a
Google
huge
Cloud
difference.
Storage, and BigQuery. These tools allow Google engineers.
Next.
Here at Google, a lot of our infrastructure is
We have more
custom-made.
servers here.
This gives us the flexibility and performance we need to run all of our services.
There's the guard.
Virginia, one of our network engineers.
Hey, Cindy.
Keeping an eye on him.
Today I'm working with hardware ops to expand this data center network to deploy additional machines.
Alright, next.
Find our network so that this particular server
running in our data.
Let's keep going forward and let's find out more interesting things. We actually do a tour. You can watch the whole video on Google Cardboard. But let's just skip. Come on. Blah blah blah. Horsepower.
Compute and networking horsepower required to run your workloads in the cloud.
This one. Okay, another section. What is this section?
BigQuery, or storing it in Google Cloud
Wow,
Storage.
that's a-
Stored on a physical
There's the
device.
guard.
Our data center infrastructure accesses our storage quickly and securely. At our scale, we need. From the time a disk is removed from the server to the time it's decommissioned, we maintain a very strict chain of custody. Let's go shred some hard drives.
Alright, so when they like upgrade hard drives, right? They need to shred it. Meaning not only do they wipe the data, they put it in this machine and they like shred it to pieces. Why don't they just donate it to charity, right? Because it can be compromised, like it can be extracted. So you really
We need to cool
like
and
crush
power
it.
our
It's very
infrastructure
serious.
in an environmentally sustainable
Where's the guard?
and reliable way. Let's take a look.
There. It takes security very
Welcome to the
seriously.
mechanical equipment room. Pretty cool, doesn't it? Okay,
What is
Brian,
this?
one of our data center facilities technicians. Hey, Brian.
This is their, they have water from the data center floor, pipes.
Generated on the server floor. And that all has to be
And
removed. And
there's
that's
the guard.
right here.
There's the
Basically
guard.
two loops. We have the condenser water loop and we have the process water loop. The process water loop are these blue and red pipes over here.
going.
So they take the heat exchangers here. We started reporting our low, helping the cooling tower do.
So now they went out. This is outside the cooling towers.
So Sandeep, this is a cooling tower. It uses
tower.
to rapidly cool the water
Looks like a
from the
container
condenser
van.
loop and sends it back down to the
All
basin.
right.
You could say we're making actual clouds.
There's the guard. Oh, wow. Oh, I pressed the bad button. I pressed the back button. And finally, the last part. Let's just look at the last part. Let's see.
This power substation. Let's go take a look. So this is the
now they have their power supply.
substation. This is where the high
And
voltage
even
power
there, I
enters the
think there's
site,
a guard
it's
here.
reduced and then sent to multiple power distribution centers.
There
such
he
as
is.
this one right here. What happens if a power distribution center loses power? If it loses power, we have multiple generator.
So as you can see, if you like to check it out, just use the Google Cardboard. That's a great experience. Go to the whole video if you're interested in those stuff. But what you can see is that even then, like it was, jokingly like looking at the guard, but he's really there. Like he's watching, and he's not alone. Probably somebody's watching him as well. You have security cameras and all forms of security. So another thing that Urs also talked about was just serverless architecture. This is just another way of saying no ops. Live migration, no downtime. You can migrate to a new architecture, migrate from one version of your application to another. So for example, in our company, we do a lot of deployments every single day. Like we do an average of one every 10 minutes. So amongst all our products for our clients. So deployment to production. And there's no downtime involved. So that's really great. If you care about the climate, Google definitely does. Here are some of their statistics. They have been carbon neutral since 2007. That means that the amount of carbon they emit, the data centers and everything, is offset and by the carbon that they absorb. So their goal is to be 100% renewable powered. They're the largest corporate renewable energy purchaser in the world. So they're very serious about renewable energy. And their footprint for power use against typical data center is almost half, right? So that's really great. I don't know, if you care about these things, like that gets translated into pricing. Like our pricing is done, and we know that our impact is well translated. We're also basically carbon neutral. So you can put like in your, if you're using Google Cloud, you can be like carbon neutral, except in your office. That one you have to account for. Now the next guy who spoke, this was on the day 2, was a guy named Niels Provost. He's a distinguished engineer at Google, and he talked about security. And for me, this was like a long talk, and to be honest, I found it very hard to keep focused because he was very detailed. He was very detailed about the security that they have at Google. And so who is the attacker? They have lone wolves, script kiddies, insider risk, like if that guy who did a data center tour suddenly like got a server and like, oh, I got your data. Hacktivist groups, malicious users, criminal organizations, and nation-state actors. Nation-state actors are basically like another country trying to attack your app. Like, wow, what are you doing? Now, how are they attacking? They can do distributed denial of service, spear phishing, malware, cross-site scripting, man in the middle, user error, social, and like 0 days. 0 days are like the vulnerabilities that you don't even know about. So Google is like, how do we protect ourselves from vulnerabilities that even us don't know about yet? So what do they want? They want money, intellectual property, espionage, vandalism, public perception, or notoriety. Like, they just do it for fun. They do it because, yeah, I'm a hacker. Oh, I hack Google. Oh, I have this app, look. Alert. Anyways. So they do it for all sorts of things. So this guy is in charge of protecting. And this is his slide. You know, it looks very detailed, but did you know in the actual GCP, and for those who went there, you know this, he went through all of those things one by one. Like he was like, for our hardware, we protect it by building purpose-built chips, which means we build it ourselves, and we build it for a specific purpose, and only that purpose. We build it, we didn't buy it from any provider, so if those provider has a vulnerability, then we don't inherit the vulnerability. We build it ourselves. So we know what we built, and so the security there is already built in. We have purpose-built servers, and so every server that we have, we build it ourselves by Google for Google. It's not provided to other companies, therefore it's not easy for people to tinker with, and it doesn't escape, so people can't like detect vulnerabilities in it. So it's already another layer of security. And they talked about every single one of those. Purpose-built storage, purpose-built network, purpose-built data centers. Basically, they said that, basically saying that if you wanted to hack into a data center, first you have to figure out even what it looks like, how it's built, the blueprint of it, because it's not like a traditional data center. Boot, trusted boot, cryptographic credentials. The OS IPC, this caught my attention. Which one is that? Authentication for each host and each job. So each job in the OS level has to be authenticated. So you don't have like a rogue job or something. Encryption, IAM, logging, vulnerability scanning, binary verification, source code provenance, third-party code reputation, auto-enforcement of peer review for all changes, security reviews, and in deployment, unphishable hardware second factor, TLS, DDoS protection, TLS certificate pinning. How do you name? Certificate pinning is like what you get when you like go after school, and your recognition ceremony. Best in English, pin the certificate. Anyways, operations, updates and patching, secure best practices and configurations, threat analysis and intelligence, forensics, anomaly detection, incident response, audit logging, URL reputation, binary reputation, log reputation. By the time he was done, I was like, whoa, yay, we are done. And then he said, this is what we used to do. Now let me show what we do now. And then he added all these things. And so he went over every single thing again. This guy, on his spare time, he makes swords for fun. He forges swords. I was like, whoa, he still has spare time. So it's basically much, much more than the security that we do or you maybe do. If you do more than this in terms of securing your app, I want to talk to you. All right, so definitely secure. And finally, you have Jeff Dean. So Jeff Dean, now he touched on Jeff Dean, and this guy is the head of Google Brain. So a lot of machine learning. So talked about easy to use machine learning, ready to use. Cloud Translate API available already. Cloud Prediction API available already. Cloud Vision API available already. So I'm going to talk a little bit about Cloud Vision API. There's a technical talk this afternoon. But just to let you know a little bit how it looks like, have you ever used Google Photos?
Yeah.
For backing up your pictures, right? Yeah. Have you ever tried searching on Google Photos? Yeah. Like that thing works really great. So this is my Google Photos. In case you see some weird personal pictures, just ignore it. So, but we can do a search. For example, when I went to San Francisco, I am a fan of Tesla, the car. So every time I saw a Tesla, I took a photo of it. Like, oh, Tesla! Oh, Tesla! So I back home, I saw a Tesla. And so, if we search Tesla, on my personal photos, whoa, I'm doing a demo, right? Hold on. Sorry about that. So, here. So I'm doing a search on Tesla. These are my personal photos. And it saw all the Tesla cars that I took. Even this, like I zoomed in so I can like zoom into the Tesla logo, but obviously it came out really nice. Because you zoom in the iPhone, it's not very clear, right? Like optical, digital zoom. So that's a Tesla wheel. Google Photos found it out. It's better than a human here. Like I show you this, like, what car is this? Google think it's a Tesla. What else can you search? You can search like bridge, for example. So we went like on I don't know if you know this, but this is like near the KL Tower. It was very warm. We didn't stay long, but that's my wife there. She's on the bridge. There's a bridge. There's a bridge in San Francisco. That's the bridge behind me. I was thankful it didn't think I was the bridge. What else we can search? We can search cat, because you know, very famous. Oh. This is actually the movie Captain Phillips. This is the Somalian pirate. Google thinks it's a cat. But we watched it while we were on a boat trip in the Philippines. How appropriate, right? Like, you're in a boat trip, they show Captain Phillips. Like, how appropriate. Okay, and then these are my coworkers sleeping. I caught them in the office in the morning. They did an overnight. Maybe it's because of his shorts. He looks like a cat. And you even have a slide with a cat background. And if you're a human and I showed you this, what do you see? And you'll be like, oh, it's talking about user interface. But the computer saw behind that. It saw the cat. You can't hide anything from a computer. What else can we, laptop, for example. So you can see all pictures of laptops here. So this is us in the office. You have laptops here. Now, what's interesting is that these weren't collected via tagging. Google Photos never asked me, like, what is this picture? Put a label. We used to do that, by the way. Now, it just knows right away. I think it does, it's machine learning. For all we know, it's like being, like, all the photos being uploaded is like shipped to some sweatshop and like, this guy's like, oh, label this, label. All right. We don't know. But it could be the Philippines, right? There's like some facility there that scanning and tagging everything. No, just kidding. It's really machine learning. Google can't do this at scale if they weren't doing true machine learning. And the beauty about this in Google Photos is because all of this is now being provided to us, to the public, for us to use. The same technology and platform that powers Google Photos to classify images is now available to developers for determining this. You can do label detection, face detection, OCR, explicit content detection. So Google has Safe Search. You can now do that. That's very handy for us because we have a dating app. And you can send selfies by dating app. And so we actually use this to, when you post your profile picture, so we catch explicit content before they are shown to other users. So we are a safe dating app. All right, and then you have landmark detection, and then you have logo detection. And finally, Jeff touched on TensorFlow as well. So TensorFlow is for the hardcore machine learning people. If you want to make your own models, it's not trained already. It's not yet trained. For example, like the Google Cloud Vision was ready to use. This one you can make your own models for custom machine learning tasks. So for example, we have one use case that we have like about 100. We have an app. We work with the government and the World Bank, wherein we have to classify roads in the Philippines. So the World Bank has, I think, loaned the Philippines somewhere around several billions of pesos and dollars to build roads in like the rural areas of the Philippines. And there's like war going on there. And so sometimes when they send the inspectors down, the inspector gets to near the road and then it's like, you want to go there? Many bullets fly. Here's the inspection report already with pictures. Just sign it. Here's some beer as well. And so the inspector just goes sign. So they have a very big difficulty inspecting the sites. So the app, what it does is that there's a mobile app component where the inspectors can take photos of the actual road, and then it's geotagged to that location. The image is signed so that it's not tampered, and then it's uploaded to the cloud. So Google Cloud in this case, and then we have a team of people going to the photos and classifying them one by one. Basically saying, oh, this is a concrete road, oh, it has potholes, oh, it's good quality, oh, this is muddy, oh, it's a sucky road, this one's a fair road, poor road, bad quality. So we have this. We've classified over 10,000 images already. Just we're having a team just going to it one by one. And so we were thinking, if we could use machine learning, because we have classified 10,000 images, we have for the first batch, 200,000 images to go, just for this first batch, and there are several batches to come. And so we could use machine learning to identify that. So we used 10,000 images as training data, because it's already, we already classified it. We could feed it, this is all hypothetical, we haven't tried it yet. We could feed it, but we'll definitely do this. We could feed it into the machine learning platform. We could use TensorFlow. I'm actually looking for cloud machine learning, looking forward to that. And then use that as a training data so that we can then just use the machine learning platform to give it an image, and the cloud or the Google Cloud will then just be the one to classify the image, whether it's concrete, asphalt, gravel, or soil, whether it's good, fair, poor, or bad road. So that's what we're going to do. It will save us a lot of time, and also to my team of people who were formerly classifying, they will now move to better jobs. They will be able to concentrate their efforts into more human creative tasks and knowledge. And so I think that's really the push now towards being able to do much more creative and knowledge process work. So yeah, I think that concludes my experience for GCP Next 2016 in San Francisco. This afternoon I'll be talking more about the Visual API and going really into the technical details of it. There are other code labs as well. But if you have other questions, I'll be available during lunch for you to talk to me. I'd love to talk to you as well. Thank you very much, guys.
That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels. That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels.